Good morning, all. Kindly be seated. Our chief guest is expected to arrive at any moment. Please take your seats. Good morning all. The function is about to commence. Please be seated. Welcome, sir.
A warm and vibrant good morning to one of you. I am Dr. Sinivi Pillai.
And I am Dr. Abhijit Rajkumar.
And we are the joint organizing secretaries of this international conference and this convention. On behalf of the organizing team, we warmly welcome all of you to the 67th National Convention, 9th International Conference and National Productivity Contest organized by Institute of Industrial Engineering, Trivandrum Chapter in association with Mechanical Department and CET School of Management, College of Engineering, Trivandrum.
Indeed, it's a proud moment for all of us to gather under the powerful and forward-looking theme, Industry 5.0, AI-driven industrial engineering for sustainability, a vision that marries cutting-edge technology with sustainability for a better tomorrow.
In these 2 days, we are going to explore innovations, insights, and collaborations that will shape the future of industrial engineering in the AI-driven world, with thought leaders, practitioners, and researchers converging across India and across the globe. And before we begin, we request that everyone kindly pay attention to the safety guidelines of this venue. So let's ensure that our convention is successful and also safe also. For this, may I request the person from the hotel to brief us on the safety instructions.
Good morning all. Welcome to Dimora, Thiruvananthapuram. Myself Anish. I'm just here to brief you about the safety and security of this hotel. This hotel is fully equipped with all fire and safety measures and certified, one of the certified hotel also. And now you are sitting in the first floor of this hotel. And in case of any emergency, you can use the emergency staircases both the side. I mean, out of this hole, you can go to both the side of this hotel. I mean the floor. I mean this the hole. Both the side there is emergency staircases are there. In case of any emergency, you can use the staircases. Do not use elevators at any cost. And I wish you all success to this national event. One more thing I just want to add on this. I request all of you to keep your mobile phones on a silent mode for the successful happening of this function. Thank you so much.
Thank you. So without further delay, let's officially commence this inaugural ceremony. Let us now invite the dignitaries to the dais. We welcome you with heartfelt gratitude and warmest regards.
First and foremost, we welcome Dr. A.V.V. Prasada Raju, Chairman of IEEE National Council. So request Dr. Suresh, Secretary of IIIE Trivandrum Chapter, to welcome sir. Welcome you, sir. Now it's an honor and privilege to welcome a towering figure in Indian space science and engineering, Dr. V. Narayanan, distinguished scientist and currently serving as the Secretary of the Department of Space, Chairman of Space Commission and Chairman of ISRO. Welcome, sir, to the dais. May I request Dr. B. Anil to do the honors. Welcome you, sir, again. And now we have Engineer N. Narayana Murthy, and he is the President of IIIE Trivandrum Chapter. May I have you on stage, sir? I request Dr. Bijilal to do the honors. And we have the Principal, College of Engineering, Trivandrum, Dr. K. Suresh. Welcome you, sir. And Dr. B. Anil, Chairman of Organizing Committee, request to be on the dais. So let's commence the program by seeking the blessings of Almighty. So now, to mark the beginning of the significant occasion, let us invoke the spirit of wisdom and enlightenment with the traditional lighting of the lamp. And I request our esteemed dignitaries to do it. This would be the formal inauguration of the program.
Now let us all rise and be part of the IIIE song, a tribute to the spirit of industrial engineering. Let us all rise. be seated.
IIE का ये है लक्ष्य सदा, उत्पादकता वृद्धि में ये देश की शान सदा।
IIE का ये है लक्ष्य सदा, उत्पादकता वृद्धि में ये देश की शान सदा।
कोई भार नहीं, प्रभार नहीं, ज्ञान का अहंकार नहीं।
कोई भार नहीं, प्रभार नहीं, ज्ञान का अहंकार नहीं।
अपनी मेहनत, अपनी लगन, जिसका लगता कोई दाम नहीं। करता प्रेरित इनोवेशन को ये सदा, उत्पादकता वृद्धि में ये देश की शान सदा। IIE का ये है लक्ष्य सदा, उत्पादकता वृद्धि में ये देश की शान सदा। करते हैं व्यर्थ प्रलाप नहीं, कठिनाइयों में ये बिके नहीं।
करते हैं व्यर्थ प्रलाप नहीं, कठिनाइयों में ये बिके नहीं।
कार्य कुशल संपन्न कर्मी, संस्कारों का छोड़े साथ नहीं। नेतृत्व समर्पित पाता है सम्मान सदा, उत्पादकता वृद्धि में ये देश की शान सदा। IIE का ये है लक्ष्य सदा, उत्पादकता वृद्धि में ये देश की शान सदा।
तकनीक मंथन दे उद्योग को नई दिशा।
तकनीक मंथन दे उद्योग को नई दिशा, सप्लाई चेन बढ़ाए सबका ज्ञान सदा। औद्योगिक इंजीनियरी से मूल्यों का हो वर्धन, सात समुंदर पार अपना गौरव फैलाता। स्वर्ण अक्षरों में संस्थान की लिखी गाथा, उत्पादकता वृद्धि में ये देश की शान सदा। IIE का ये है लक्ष्य सदा, उत्पादकता वृद्धि में ये देश की शान सदा। IIE का ये है लक्ष्य सदा, उत्पादकता वृद्धि में ये देश की शान सदा।
Thank you all. Please be seated.
To formally open this convention, now I invite Dr. B. Anil, Chairman of IIIE Trivandrum Chapter, for the welcome address.
Good morning, distinguished delegates, esteemed guests, and innovators from abroad, all of the country. It is my great honor and privilege to welcome you all to the 67th National Convention of IIIE, Indian Institute of Industrial Engineering, and 9th International Conference on IE and National Productivity Contest. The theme of this conference is Industry 5.0, AI-driven industrial engineering for sustainability. Today, we gather at the crossroads of technological advancement and environmental responsibility, where artificial intelligence meets human creativity for a more sustainable future. Your presence here reflects a shared commitment to shaping industries that are not only smarter, but also more compassionate and sustainable. As we explore the transformative potential of AI in industrial engineering, let us also embrace the ethical, social, and ecological dimensions of innovation. Industry 5.0 challenges to move beyond efficiency and productivity toward resilience, personalization, and human-centric progress. Throughout this convention, we look forward to the exchange of pioneering ideas, breakthrough research, and collaborative opportunities. May the discussions ignite new strategies that redefine the role of industry in a rapidly evolving world. Let me pass on to my duty of welcoming you all to the convention. The meeting is presided by Dr. A.V.V. Prasadaraju, Chairman, IIIE National Council. Under his leadership, the institution is scaling new heights. He has been a source of inspiration and support for all of us. So when Mr. Rahul Sahai, the president of the institution, could not make it, Professor Prasadaraju took up the responsibility and he is leading us from the front. I wholeheartedly welcome you, sir. Dr. V. Narayan, Chairman, Space Commission, Secretary of Department of Space and Chairman ISRO, needs no introduction. A world-renowned scientist and the expert in cryo-engineering and also liquid propulsion. He has been associated with ISRO for the last 40 years. His untiring effort and scientific acumen helped the country in achieving rare feats in space technology. He has occupied various positions in ISRO, and he was director of LPSC, during which time I had opportunities to interact with him several occasions. An unassuming and simple person who works day and night along with the team and leads from the front. He's an example to follow for all young scientists and administrators. So today also, he flew down from Delhi. In spite of all his commitments, he made it a point to be here. So on behalf of IIIE Organizing Committee, I welcome you. Engineer N. Narayanamurthy, Chairman Keltron, who is also President of IIIE Trivandrum chapter, is a leader par excellence. He is an electronic expert and was part of ISRO for 40 years. Now he is leading Keltron as chairman. He is one person who took the Keltron, which was loss-making, to a profit-making institution. Last year, it crossed 1,000 crores turnover, and it is moving forward to 1,200 crores this year. So I welcome you, sir. Dr. Suresh is the principal of CET. CET is College of Engineering Trivandrum, is the first and lead engineering college in the state. Of course, he is also part of the organizing team because CET is co-hosting this institution. CET Department of Mechanical Engineering, Dr. Karthika is there, head of department. And CET School of Management, Director Suresh Subramani, he is also here. Okay, they are hosting this, co-hosting this conference. So I welcome all of them. I also welcome all NC members, because I don't have enough time, so I'm just not naming all of them. Okay, all NC members, all invited guests. Many of them are Professor Dattani is there, and many others. So I don't want to name each and every one of them. Mr. Mohan is there. Mr. Rajarajan is there. They are a director from VSSC as well as LPSC. And of course, we have IEEE veterans, Professor K. Gopalakrishnan sir, R.D. Pilla sir is there. Okay. And experts and speakers, chapter council members, delegates, guests, media persons, because they have been a great help. Press, then volunteers. We have an army of volunteers who are helping you around. National headquarters team. Yesterday, they have been working hard to make this a success. And all others present. Of course, I forgot to mention the sponsors who have been generous enough. Some of the chapters were generous enough to help us. So I thank them all and welcome all of you to the God's own country. You have a nice time.
Thank you, sir. We now request Dr. A.V.V. Prasadaraju, Chairman of IIIE National Council, to deliver the presidential address.
Good morning, sir, ladies and gentlemen. I thank all the delegates here arriving in the fine sunny morning to the God's own country. And without wasting much of time, I thank our chief guest, guest of honor, and other dignitaries on the dais and off the dais. So today we are here to inaugurate the 2 days annual convention along with other flagship events of our prestigious institution on the theme of Industry 5, driven by AI and other advanced technologies, which focuses on creating the sustainable, human-centric and industrial systems. Generally, we have a key aspects to discuss. Those are embedded in the curriculum in various institutions, those things being practiced in industries. On those aspects, we are here to deliberate with the latest developments, such as human-centric approach, sustainability focus, and resilience and adaptability is the main key points. We have a lot of advantage technologies today available in the globe. That is AI and machine learning, IoT, robotics and automation, digital twins, 3D printing, and virtual reality. So those things become part of institutions' growth as well as a part of Indian Institute of Industrial Engineering. We are also adopting those subjects in our graduationship examination. So Industry 5 should practice definitely a personalized product design and manufacturing, optimized energy consumption, circular economic initiatives, and invoked worker safety and well-being. So with these few points, I open this. I request all the session chairpersons, productivity contest leaders to focus on this and encourage the future industrial engineers sitting over here and participants and contestants for the productivity council. So with this, I close my inaugural speech and welcome dignitaries of the dais and non-dais. Thank you very much.
Thank you, sir. We are honored to invite Dr. K. Suresh, Principal of College of Engineering, Trivandrum, for his address as a guest of honor.
Dignitaries on the dais and off the dais, delegates, faculty members, I am privileged to stand before you co-hosting the August event of 67th National Convention of Indian Institute of Industrial Engineers, along with 9th International Conference and National Productivity Contest. IIE is a professional body established in 1957, serving the area of industrial engineering, giving a platform for the interconnection of industry experts, faculty members and students to increase productivity, efficiency, and in the field of engineering and engineering. Right. So College of Engineering Trivandrum was established in 1939. It's one of the premier institutions in India. We have the speciality of offering a UG program in industrial engineering and also a PG program. And also we have a PG program in financial engineering. And we have an MBA program. We have a School of Management which runs MBA program. So it is aligned with the deliberations of or the activities of Indian Institute of Industrial Engineering. We have a strong faculty group working in the area of industrial engineering, many researchers and leading researchers. And all these faculty members are future centric because we have introduced new aspects of industrial engineering, what is AI and machine learning concepts into our curriculum. If you look into the curriculum, even the industrial engineering curriculum was very updated, and they have the forethought to introduce modern techniques very early, even before computer science department started working on AI and all. So that is, so we are actually privileged to be here in this convention. Now we are moving into a phase where there is a lot of disruptions in the field of every field because of AI. It's affecting every area. So being relevant is very important. So if you are not adapting the changes and adapting the technologies which AI offers, you will become irrelevant, right? So if you have a programmer if a very proficient programmer, if he is not using the support of AI, AI agents and all that in his professional work, any more mediocre programmer can overtake him through the skills through this AI. So that is true for every field. So if you are working in law, if you are working in administration, if you are working in content generation, so it's a very disruptive thing. So this disruption is not new, right? So in all stages of human development, there is disruption in job, disruption in skill sets and all, right? So the skill sets very relevant in the hunter-gatherer time is not relevant now, right? So that change is always there. But the difference is that the pace in which the changes are happening. So it is very, very fast. The changes happening in this field is very fast. We are really concerned about our what skills should be given to the students, what skills we have to focus so that our students will be employable and relevant to that. So thinking on that, what we feel is that, so we have to look into the basics of strong in your base, and you learn to learn, right? So it should be a continuous learning, right? That's only we can be relevant and we can survive in this changing world. So I hope that the deliberations in this conference will look into all these matters. It's already there. The theme is very relevant: Industry 5.0, AI-driven industrial engineering for sustainability. I extend a wholehearted support from College of Engineering Trivandrum for this event, and I also thank the organizers for allowing us to co-host the event. Thank you and all the best.
Now it's time for the much awaited inaugural address. A stalwart of the Indian Space Research Organization, Dr. Narayanan has over 4 decades of service, including as a former director of Liquid Propulsion System Center, LPSC. He is a globally respected expert in rocket and spacecraft propulsion and has led the development of India's cryogenic engine systems, placing India among the elite group of nations with such capacity. He has also played a critical role in several landmark missions, including Chandrayaan-2, Chandrayaan-3, Aditya L1, and the ongoing human space flight program. Dr. Narayan's technical and leadership contributions has been widely recognized with over 26 prestigious national and international awards, including the APJ Abdul Kalam Award, Gold Medal from the Astronautical Society of India, and most recently, the 2024 laurels for the team achievement for Chandrayaan-3 and by the International Academy of Astronautics. We are deeply honored to invite our chief guest, Dr. V. Narayanan, who is currently the Secretary of Department of Space and Chairman of ISRO, to share his insights with us. So, ladies and gentlemen, let's give a huge round of applause and welcome our chief guest.
Very good morning to all of you. Most respected President of IIE National Council, Dr. A.V.V. Prasad Raju, Dr. Suresh, Principal of one of the best engineering colleges of the state, College of Engineering Trivandrum, Dr. Engineer Narayanamurthy Sir, President IIE Trivandrum Chapter, one of our mentors, one of the very successful project directors of the PSLV, and a very highly accomplished technocrat. And today you all heard how he has changed Keltron from a profit-making company. I think let us give a big hand to him for that great accomplishment. On the stage we have got Dr. Anil, Chairman Organizing Committee, Dr. Dattan Sir, one of the mentor of me, who really groomed me in the appropriate time and contributing the cryogenic program, and the directors of VSSC and LPSC, Mr. Rajarajan and Mr. Mohan, and very distinguished personalities we are having here from College of Engineering, Trivandrum. Also, KVSG, Murali Krishna, the VC of JNTU, Kakinada. I think first cut itself, I am touched up by your book. Anyway, I have decided to read. Maybe today evening I have to travel back to Delhi. So 3 hours time, hope I will find time to read your book. And Vayu R. Karware, CMD from Pune, Karware Fibers Limited, and award winners, IEEE council members, and press persons, and my dear friends. Once again, my greetings and good morning to all of you. Really, I feel privileged and honored to be among this very, very distinguished audience on the inaugural function of IEEE conference. That too, it is the 67th annual convention and 9th international conference on industrial engineering. I understand this society is formed in the year 1957. And you all know 1957 was a very, very important year in the space activities. The Sputnik was launched by, that was the first man-made satellite which was launched by Russia in that year. In 1957, we were not having any activities in the space, but then today, we have come a long way. I will come back to that little later. And I was thinking, to be frank, till 3 days back, I was not planning to come back because yesterday I was having full-time work in Delhi. And again, today night, I have to reach back to Delhi. I thought I will skip this function. But then, 2 of the colleagues who are responsible, Mr. Suresh Kumar and Anil, when they met me directly, I had to come back. Whatever may be the situation, came back only early morning, 2 o'clock, and again returning today evening. So let me also thank them. Because of them, to be frank, I am with you. Now, this, the industrial engineering topic is a very, very important and interesting topic. But as a student, I have not enjoyed the topic, to be frank. I happened to study first time in my diploma. The final semester, there were 2 papers you had to study. One was a compulsory paper called Industrial Engineering, little dry subject. That's what I felt at that point of time, talking about rules, regulations, productivity, work study, PERT chart, CPM, so many things. And also, I had taken an elective subject called work study and production planning and control, and my teacher, I have to salute him. He brought us the book written by the ILO, International Labour Organization, on the work study and production planning control, and he was telling for a diploma standard it is a little high level, but doesn't matter, better you study this so that up to MBA same book will be followed. So that is the way that book was brought to us and studied and thoroughly enjoyed. And today, to be frank, I have reached to this level. Of course, technology, lot of things we have done, but one of the important thing is that industrial engineering background and work study and production planning, whatever I have studied, every part of my life. And I was the project director for some time, and he was the project director. Narayan Mursar was the project director of the Mark III project. I was the deputy project director in the C-25 development. Later on, I became the project director. Every walk of life in ISRO, as well as private companies, I have worked 2 years, 1.5 years. Every time this topic has really helped in a very, very big way. And recently, I want to tell, we are having something around 65 projects, 65 project directors. So I can be very open. When I was reviewing the activities, I was asking them to present the PERT chart. And half of the people were confusing between PERT chart and simple bar chart. So they were putting all the things. And today I want to tell, we have instituted a system. All the project directors, project executives, we are giving a coaching on the industrial management and this type of aspects. And it is in that context when I was thinking, what is this industrial engineering? What about? I was just morning only I was thinking. It talks about the area on work study, O&M, production planning and control, materials management, value engineering, PERT, CPM, operation research, computer science, finance management, statistical quality control. And there are so many emerging systems. If a project director has to be a successful project director, without the knowledge on industrial engineering, I don't think anybody can be successful as a project director. And if somebody has to succeed as a good industrialist like Narayana Murthy sir, And some of the things we don't learn, but we practice. Without our knowledge, we practice how to become a good industrial engineering expert. And in fact, this area is not only useful in industries, it is also used in multiple places. Take hospitals and supply chain management in the food delivery industries. So everywhere, this has got a great role. So thereby, I think the excellent August audience we are having for this. So let me come back my own experience on this particular area. I joined immediately after my diploma background. In fact, my entire higher education was only in ISRO. My engineering, MTech, PhD, everything was in engineering here. Before that, I worked in BHL. BHL, we were 80 people selected, and finally, after the 6 months training, they had to allot the area of work for us. And when the area work was allotted, I opted for operation planning and control area, because I was so much interested in that area, because once you are in that area, you will understand very short time the entire dynamics of the organization. That is the major advantage. And the industrial engineering background people, really they are on high demand. In fact, I don't know how many of you are aware, IIT Kharagpur, there is a MTech course called Industrial Engineering and Management. And of course, I was one of the MTech students, best outgoing students at that point of time. But by default, I can tell you, the people who join there for industrial engineering, they are the best people who join. Because out of 20 students, mechanical 2 seats, chemical 2 seats, computer science 2 seats, like that it is distributed. And they understand, study everything. And now coming to the ISRO programs. ISRO programs, I want to tell I was 7 years, I was working as the director of Liquid Propulsion System Center. And initially, there was a thinking. I'm a core designer and technocrat after my MTech in cryogenic engineering, core designer of the cryogenic rocket engines. So, generally the designers, they feel they are the superior class of people at that point of time. But initially, I was thinking like that for a few years. But as time passes, you understand that if the designers alone are doing fantastic job, the rocket and satellite will be only in the paper. And no rocket, no hardware will come out, no satellite will come out. So it is the all branches of engineering, including material science, manufacturing, industrial engineering, everybody has to work together, then only you will see the product. And industrial engineering people have done outstanding work in our organization. Whenever you talk about a project, there will be a project management office, and there are the people who really run the entire show to roll out the products. And of late, just before I left as the director, you can understand we were having 10 entities. Each entity, we appointed one person with MTech industrial engineering background. Then you can understand the importance of that topic, how much it was given. Because they are the people who understand the overall dynamics, and overall, when you talk about productivity, when you talk about the machine loading, man loading, and optimized utilization of the entire resources, the productivity. Production is little different from productivity. Productivity, I think I need not explain to this audience how to improve the productivity of every person, every activity. And these are all the people who do this. And follow-up is one of the things. In fact, when I studied 1982, the functioning of work study and production planning department, the last function out of 5 functions, the last function is the follow-up activity. Follow-up looks like a simple word, but it's a very tough job, because you are interfacing not with machines, you are interfacing with human beings of different chemistry, different characters. And then you should jive with everybody. I think Dattan sir have come in a long way, handling different type of characters and succeeding with everybody. And one of the successful directors, you please understand, he was the director for 3 centers. Nobody has got that opportunity. He was the director of Sririkota, then he became director of LPSC, he became director of VSSC. And then you can understand the variety of people, how he has handled, how he has really done great thing. And when he was the director, we had the first successful indigenous cryo successfully fly. That also happened when he was the director. And then this person who is sitting here, Mr. Narayana Murthy, don't take him very light. Very, very simple person, very nice language he will talk. very taskmaster. Taskmaster, not by rubbing me, very decent language, very pleasant language he will talk, but ensure everybody is delivering things. And that is the type of people we are having. Dear friends, today we are here. At least I should share a couple of great accomplishments of ISRO. You know, the Indian space program was started in the year 1962. 1963, November 21st is an important day, you all may be knowing. A tiny rocket was donated to us by USA. A small rocket. The Nike rocket was given, and the payload came from France, and then we assembled in Tumba and we launched. And August 1st, 1975 is another historical day. At that point of time, the top leaders of the country were really not convinced about space program. In fact, I was told that people are questioning why India needs television sets. Yes, you can understand, 1947 when we got independence, 97.5% people were below the poverty line. And average life of Indians were hardly 32 years. That means people were dying the age between 25 to 40. At that point of time, somebody is talking about space, human space flight, who will appreciate? And people were not convinced. It was 1975, August 1st. 2,400 television sets were kept in 2,400 villages of 6 states. And we requested a signal, again, satellite signal from America. From the ATS-6 satellite, the signal was sent. And we demonstrated for the first time the mass communication through the satellite technology. And 1969 ISRO was formed, 1969 August 15. And please understand, 1963, when America is donating a tiny rocket, they are building a rocket to place the 125 ton to low Earth orbit. 125 ton satellite to low Earth orbit they are building. At that point of time, they are donating a satellite. This is equivalent to, today, ISRO is having a 700 ton lift-off mass rocket. If I donate a RH-125 rocket of something around this much height to another country for studying rocket technology, what we'll be thinking about them, that was the thinking at that point of time. From that, last 50 years we have grown, and exponentially grown. Today, last month 30th, we placed a satellite called NISR satellite, NASA ISRO Synthetic Aperture Radar satellite. There are 2 important payloads. One is a L-band SAR payload. 10,300 crore is the amount what is spent by NASA and JPL NASA. And we have built another payload. And the satellite is made by us and placed in orbit by our launcher, the GSLV Mark II. And today, a country which was just requesting for a small, tiny rocket, we are rubbing shoulder to shoulder with the developed countries in the space technology. That is the type of growth what has happened. Now, these 6 months, last 6 months, there are 3 important activities with the developed nation USA. One was, the Axiom program. The second person, Subhashnu Shukla, we sent it to space, and the first person, we sent it to International Space Station. And you all know he is sent safely and he has come back safely. But there is little background on this. The role of Indians. The entire program was conceived by Honorable Prime Minister because he strongly felt for the Gaganyaan program, we are working on the Gaganyaan program, but to send a person so that he will gain confidence, get lot of knowledge. And with that, this program was conceived and executed by ISRO. And Subhashnu Shukla is ISRO employee today. Even though earlier he was in Air Force, now he is ISRO employee. And myself and Mr. Mohan, he is there as the director LPSC, you can see him. And along with that, some 18-member team, we were also there in USA. And we had a great role to play in that important mission. Originally, the actual launch happened on 25th June this year. Original launch was scheduled, originally 29th May, then it was shifted to 8th, 9th, 10th, finally it was scheduled 11th. And on 9th, we had a meeting with them. The rocket was moved. After moving the rocket, the first stage is having 9 engines, and they are supposed to do a ground test, 7-second test. As per contract, they are not supposed to tell anything to us, because our contract is with a private company. And finally, we asked what happened to the test. They told everything is fine. And 3 committees have cleared the test result. And the launch was scheduled on 11th morning, June 11th morning. And 10th early morning, there is a small news item I am reading. Morning 4:30 when I got up, I am reading a news. During the test, there was a minor liquid oxygen leak. To handle that, they are purging with helium. This is the only news item. And otherwise, everything is in order and launch is scheduled. And we demanded a meeting to understand what was the thing. And they were not ready to explain because, it's all developed countries. And then they told it's a very, very minor thing. Why we are wasting our time today? Because next day morning, 8:30 is the launch. And myself and Mohan was there. We were demanding morning 11 o'clock onwards. And nobody was bothering, and by noontime somebody came and tried to explain several minor things, everything is in order. Then we asked, if I'm correct, 14 questions were asked, only one question was answered. Finally, we had to give a letter stating that, no, we are not convinced, unless the leakage is fully resolved, the rocket cannot take off, we are not going to participate. This is a letter effectively given. And it was a very embarrassing situation because 6,000 people from throughout the world as committees. It is not only our astronaut, 3 more countries' astronauts are there. Finally, the launch had to be called off. On 10th evening, 5:15, launch was called off. And then it went to the highest level. Then they told what are the questions asked. One of the questions what we asked, simple questions only. Where is the leak? Anybody will ask, And then even for that answer was not there. Then they had to locate the leak. Next day morning, they came and they told they have located the leak. That was a happy news. And leak is because of a crack in the main field line. Then we asked, why don't you launch? Then nobody will launch with that crack. Surely if the launch would have taken place without our interference or our intervention, this would have entered with a big catastrophic situation. And today we are very happy that the Indian education system, ISRO knowledge, ISRO technological background has ensured calling of stopping a launch and ensuring. Finally, everything was corrected and Subhasanu has gone safely and he has come back safely. It is ISRO team which ensured calling of the launch and correcting and ensured the safety of 4 astronauts. So that much I want to tell. So then third program we are working with USA is in another 3 months. We are going to launch a Bluebird 2 mission. Bluebird 2, a 6,500 kg communication satellite, which is going to be lifted off using our Mark 3 vehicle. Thereby, you can understand 50 years back when we were tying our rocket in bicycle, I think those are actual photographs, not the artistic pictures. And from that, we have come a long way and you have grown to very high level. And to our credit, lot of satellites are launched, 132 satellites. And right now, 56 satellites are in the orbit. And Sintur operation, you all know, Sintur operation, the ISRO team has ensured whatever possible for ensuring the safety and security of every citizen of Bharat, we have ensured. I cannot talk beyond that in that topic, but we have ensured that we have done. 6 generations of launches we have developed, and we have launched the first rocket 1979, SLV-3. The project director was none other than APJ Abdul Kalam ji, and one of the greatest son of the India, Professor Sadish Dhawan was the chairman, and of course there were a lot of people who were working for that program. But we claim that success is only 95% because the mission could not be accomplished. Rocket was built, everything. But then the 100th launch, next major milestone we consider as the 100th launch that happened this year, January 29th. You can understand, the entire ISRO team was so much enthusiastic, tensed, but then we were confident on the launch day. But today I want to tell, it was a perfect 100th launch which was accomplished, and we are written in the golden letters of Indian space program and Indian history. It was a grand successful thing. Coming to application, 1975, 50 years back, there was no space application, honestly speaking. Space was there, but no space application. But today there are 55 space applications, telecommunication, television broadcasting, weather forecasting, disaster warning and mitigation, navigation, and strategy management. There are so many places we serve the country. And without space application, we cannot think about India today, to be frank. Now, 35 years back, there used to be a program called Chitrakar. And Malayalam, exactly, I don't know equivalent. Tamil, there was a program, equivalent program was Oli Mulium. Every week, Friday evening, 8 o'clock to 8:15, if I'm correct, 5 songs used to be played. And if you miss that songs, you have to wait for 1 more week. That was the situation, and today, what has happened. And telecommunication, there was a time, if you have to make a 35 years back, or 40 years back when I joined ISRO, if you have to make a phone call from here to Delhi or to Delhi, to Ernakulam, what has to happen? You have to go and wait in a trunk booth, and you will book, and there will be a lot of friends standing on the queue. And unfortunately, the moment you get the connection, within few minutes, it will get disconnected. Then everybody will be pressurizing you, please don't attempt to, please come back and stand in the queue. I have come. Tambanur, I have come like that. I have come in the queue once again. And today, from that, where we have come, really satellite technology has done great thing. Disaster warning and mitigation, lot of good things are done. There was a time, lot of people we used to lose, including tsunami, flood, cyclone. But today, we have not solved the entire problem, but to some level things are done. And everywhere we are moving forward. 9 places, India is number 1 in the world today. 9 places. Chandrayaan 1, finding water molecule, we are number 1 in the world. Chandrayaan 2, we are having the best camera. Who is having the best camera in the orbit, moon's orbit? It is India is having the best camera in the moon orbit. And Indian's photograph is the best photograph. 32 centimeter resolution. And Mars orbiter mission, we have accomplished, and 69 crore kilometers we have to go. And not only going, the rocket, this satellite is going with a high velocity. And after that, you have to capture operating engine system developed in Valiyamala, in Thiruvananthapuram, after 295 days. Somebody is going on a vacation for 2 months and coming back and starting the car. You will understand what is restarting after 2 months. But here after 295 days, everything was perfectly done. India is the only country, first country succeeded Mars orbiter mission in the first attempt. None of the developed country could do. And 1957, when you started your organization, that time the Sputnik was placed in orbit. Same country had a record of placing 37 satellites using a single rocket. We all debated, I think Dattan sir may be knowing, Narayanamurthy sir may be knowing, full debate happened in Tumba. Finally, a decision was taken, we will place 100 satellites using a single rocket. Placing 100 satellites is very easy, but it should not hit each other. That is the tricky job. And India is the first country which placed more than 100 satellites, 104 satellites, using a single rocket and made that world record for years to come. And of course, today USA has placed, but doesn't matter, 132. Given the opportunity, we can place even 200 also. So we are not competing with anybody, but we are the number 1 there. And the propulsion technology, cryogenic technology, the rocket engines have to take. The car engine and rocket engine, there is not much difference, honestly speaking. The car engine, what does it do? It takes either human being or objects from one place to another place. Rocket engines does same job. Either it takes satellite from ground to orbit, or it takes human being from ground to orbit. This is the job. But the difference is, car in Trivandrum maximum 70 to 80 km per hour only we can travel in Trivandrum road. But cable take car maybe 120 km per hour. To place a Chandrayaan 3, we have to give 37,000 km per hour velocity. So that type of engines we have to develop. So the cryogenic engine is one of the best chemical engines. This technology was denied to us. And other countries strongly felt that if this technology is denied, Indian space program will be limping. This is what is the idea. Today, thanks to those countries which really denied the technology, today, Indian education system, Indian scientists, ISRO team, and along with the industries, we have 3 engines, 3 propulsion systems we have developed, and India is one among 6 countries having that technology today with us. That's why our program is going fantastically well. Not only that, when we were developing, I think Murthy sir, he was the project director of Mark 3, driving us, and Kunnikumaran, one of his close friends, he was the project director. Later portion from him, I took over as the project director, and 5 years I was the project director. During the development, we have made 3 world records we have made, a technology which was denied. Only with 3 engines we have succeeded, and between engine test to flight compared to world history of record of 34 months, we have accomplished in 28 months, and a stage level test against 10 months of world average time, we have done in 34 days, and we are having 3 world records, and number of places we are becoming gradually world leaders, and lot of things are done. And right now 56 satellites are in the orbit. Another 3 years we want to make it to almost 3 times of this number. And then we are going to have our own human space flight program. We are going to have the Chandrayaan 3 is a very important thing, you all know. India is the only country, first country soft landed near the south pole of moon on August 23, 2023. This was another historical feat what was done. And we are working on Chandrayaan 4, Chandrayaan 5, and we are going to have our own space station. And we are going to we are building a rocket, first rocket SLV-3, whatever we developed, the capability is only 35 kg to low Earth orbit. Today we are building a rocket, conceiving a rocket to place 75,000 kg to low Earth orbit. You see what is the type of growth, what has happened in the Indian space program. In a nutshell, I can tell by 2040, based on the vision and direction given by Honorable Prime Minister, we will be in par with any other spacefaring nation in terms of launcher capability, in terms of satellite technology, in terms of application, in terms of ground segment, everywhere we will be in par. One should go to Sriharikota to understand our infrastructure. When Dattan sir was there, one of the propellant plant, 207-ton propellant motor case, we can cast 207 tons in a case, and Mark 3 that is there, so you should see the huge facilities. We are having launch pads, and come to VSS, you can see the facilities. Huge infrastructure is built, and I can only summarize, in summary I can tell, by 2040, Indian space program will be in par with any other country in terms of all the capabilities, and will be contributing for the Viksit Bharat of 2047. In fact, we want to be a little advanced. 2047, before we declare, we should be advanced. Now, towards this, the success of Indian space program is not only by ISRO team. ISRO team is yes required, but all industries. There are 450 industries who are supporting us from Kashmir to Kanyakumari, and east to west. People are supporting, and there are a lot of industrial partners here. Mr. Salahuddin ji, he was earlier with us, now he's a great industrial partner. There are so many people, I think I don't want to mention. And now, when you talk about the Indian space program and its growth, we strongly, this organization is a successful organization because of a couple of reasons. Number one, we strongly believe in teamwork. Number two, we strongly believe the organization and the country is above individuals. We strongly believe that merit only should rule in ISRO. We strongly believe. And there are reasons. And the role of industrial engineering graduates. Industrial engineering graduates don't think that the people, those who have really practiced and studied industrial engineering, the people who came to the organization of late, they read and understand. I have studied one or two subjects, but my topic, after I joined, within 3 months, I was given one book by my boss, Mr. Chattanathan. He gave a book because we had to draw a PERT chart. Then he called me and he told we had to draw a PERT chart for PSLV nozzle production. Honestly speaking, I know only few sentences in what I have studied. He gave a book, PERT chart. So 4 days I studied end to end, then draw a PERT chart. So the practicing engineers. And today, I cannot imagine a ISRO, I cannot imagine a industry without the knowledge and background of practicing industrial engineering people. So it is in that context, I know each and every one of you are so important in your own organization because of this knowledge and background. Also, the teaching faculties, they are all, to be frank, I see the teaching faculties are so close to my heart. Because for me, my teachers and my superiors, 13 bosses I have reported in ISRO, whenever I talk, I think they are gods. With that only I talk to them. So all my teachers I look at in that direction only. So with that, I think I don't want to dwell further. And let me thank all the industry partners, those who are supporting for Indian space program on this occasion. And also the CET team who is co-hosting. All your alumni, including Rajarajan Mohan, 2 directors are sitting there. So in our setup, director and chairman, to be frank, the gap is very small only. There is not much gap, and so your alumni are really doing great job. So let me also thank the principal and CET team for that wonderful contribution of the CET for Indian space program. And with that, I know the 2 days program is going to be very good, and you are all going to enjoy. So once again, let me thank the organizers for giving me this great opportunity to be with you on this very important day and with a great August audience. Thank you. Jai Hind.
Thank you, sir. Thank you for sharing those insightful life experiences as well as the historic moments in ISRO. Really, the country is proud of you. Thank you, sir. Yeah, we can have a standing ovation. Thank you all. We now move to the release of the Book of Abstract, which will be done by Dr. E.N. Narayanamurthy, President of IIIE Trivandrum Chapter. And this book, once it is been released, it will be handed over to Dr. Narayan, sir. Thank you, sir. So now we have another book release. Next, we have a speech. So we'll be going for the next speech, that is celebrating the excellence of IIIE. So I invite you, sir.
Very good morning to all of you. Respected Chairman IIIE, Dr. A.V. Prasad Raju, most respected ISRO Chairman Dr. V. Narayanan, Levin, and other distinguished members from various institutions, and also delegates of this prestigious conference. So as President of this IIIE Trivandrum chapter, I extend you a warm welcome for this two-day conference. Of course, the topic is very relevant, but slightly confusing topic because still the Industry 5 is evolving. Because the industry transition from Industry 4 to Industry 5, though in general definition it simply says it should have a human-centric approach. What is that human-centric approach? How to make an Industry 4 practice which has focused on total automation and productivity. Where is that particular intervention? It is industry specific and is being debated. I will come back to that later. But before that, as you all know, this two-day conference is extremely important from the industrial engineering point of view, in today's scenario especially, because the country is facing turbulent times. We as industrial engineering society and industrialists have a great role in bringing back glory to India. This conference, actually we received 150 technical papers, out of which 70 technical papers have been chosen, and that will be presented over a period of 2 days. And we have scheduled a productivity contest where 25 presentations are there. Then of course 10 invited speakers are there and 2 panel discussions. So it is a heavily loaded program for the next 2 days. So I cannot be talking a long time because already Dr. Anil Kumar has sounded me to cut short. So before I go to the Industry 4 transition and to Industry 5 and other aspects, see, as I told, now you know, I represent Keltron, now Kerala State Electronic Development Corporation Limited. Many of you have been knowing, this is the first electronics development corporation in the state public sector, established in 1973. And at that time, Dr. K.P.P. Nambiar, who was working in Tata Electronics Nelco, has championed this class. And many of you may be knowing that Keltron was a pioneer in entertainment electronic systems during the period from 73 to 1990. So in fact, Keltron was the first in the country to release color TVs. Keltron TV was very famous. In 1982, when Madam Indira Gandhi was the Prime Minister, she asked Dr. K.P. Pinambiyar, I don't want, in the Asian Games, I want color TVs. So this was the first attempt. And of course, from there, you name any entertainment or industrial product, it was there. Because at that time, of course, there was a limitation with respect to multinationals, collaboration and other things. In spite of that, many industries were started in Kerala. And now, we are very proud to say that the Keltron is the only public sector undertaking electronic corporation still having manufacturing in strategic sectors, especially the sonar systems for Indian defense, naval defense. You name any Indian naval ships, there will be 3 to 5 products of Keltron. And we are manufacturing acoustic hydrophones, and one of the leading industries of manufacturers of capacitors, 35% market share. And last year, India's first supercapacitor manufacturing with the ISRO technology was established in Kannur. And of course, you name and also you name any nuclear power corporations in India, it will be Keltron power related UPS systems and battery charges. So Kerala is having industrial base through Keltron, and of course the biggest industry in Kerala is the Nest SFO, who are doing many contract jobs for multinationals. See, now as we move from Industry 4 to Industry 5 transition, see, the focus is on many things, but the most important point to be addressed is on skilling, human skilling. Because now we have to match because Industry 4 focused on mainly on automation with IoT sensors and AI driven. But it is a very sad part on our thing that though we call everywhere IoT sensors, even these IoT sensors, most of them are imported. It is not made in India. So even for that automation, we are heavily dependent on imported sources. Then now, with respect to the transition, the skilling is very important. So skilling is very important. So the national mission on skilling and also the role of Kerala government, ASAP, as well as Keltron in skilling, this development plays a very important role. When we talk about skilling, it should be in advanced areas because we are now going to compete with the machines on a human-centric approach. So it should be on digital twins and AR, VR based training programs and other things. So yesterday when I was listening to a talk by Gautam Adani at IIM Lucknow, see, he was making one comment, very valid point. Most of the management institutes teaches us so many charts to tell how to minimize risk. But his point is, if India has to grow, Management Institute has to now teach maximize productivity with the cost competitiveness. That is the role of now IIE in the years to come, in the days to come, where India is going to face a major challenge in the tariff war. So my time is constrained. So anyway, I am sure this two-day conference will be a great success and a learning experience for all of us. So I wish this conference all the success, and once again wishing a warm welcome to all the delegates who are participating in it. Thank you.
Thank you, sir. Thank you, sir. We have one more event, that is the release of another book. This is written by one of the organizers. She is one of the co-coordinators of this whole event. And she is Dr. Sinivi Pillai. The book is on Microsoft Power BI Essentials. So I invite Dr. V. Narayanan to hand over the book to Dr. A.V. Prasad Raju. Celebrating excellence, we now begin the III NHQ Award ceremony coordinated by Dr. Sasmita Tripathi, Vice Chairman IIII NC National Council.
Thank you. Namaskar, a very blissful morning to all present. Distinguished dignitaries on the dais, Honorable Chief Guest Dr. V. Narayana, Honorable Chairman IIII Dr. A.V.V. Prasad Raju, Chairman IIII Trivandrum Chapter, esteemed NC members, valued IIIE members, and the intellectual pool of delegates and audience. First of all, I'll thank Trivandrum Chapter for giving this wonderful experience in this wonderful location. And I'm really honored to get this opportunity to announce the IIIE Awards, National Awards for the year 24-25. So we'll start with the honorary membership awards. So basically, in this awards, we acknowledge the significant contributions of all the individuals and organizations who have contributed dedicatedly. I'm doing it. So we'll start with the honorary membership award, and this will be given to Dr. K. Narayana B. So, who is the Secretary, Department of Space, ISRO, and I would request A.V.V. Prasad Raju, sir, to give that to sir.
And as a token of love and As a token of love and appreciation, we'd like to hand over a small memento to Dr. V. Narayanan. Thank you so much, sir. Your presence means a lot to us.
Now we'll move to the next honorary membership award, which will be given to Professor K.V.S.G. Murali Krishna, Vice Chancellor of JNTU, Kakinada, Andhra Pradesh. Next honorary membership award will be given to Shri Vayu R. Garware, Chairman and Managing Director of Garware Technical Fibers Limited, Pune. Thank you, sir, for your presence here. So we'll proceed. For the next honorary membership, I have already invited Shri Vayu R. Garware, sir. And I would request Chairman IIII NC Dr. A.V.V. Prasad Raju to present the award to Garware, sir. Next is the Frederick Taylor Award, which is being given to Professor Dr. Rajesh Suresh Prabhu Gaonkar. Sir. Sir, I would request you to come up to the stage. Thank you, sir. So next, I would request Mr. Abhijit to come up for the Ratan Tata Cup presentation.
So this year we have a new award which has been constituted by Dr. A.V. Prasad Raju, and the award receivers are Dr. Sasmita Tripathi, Associate Professor Mechanical Engineering, Siksha O. Anishandan University, Bhubaneswar, and Dr. Kiran Chowdhury, Vice Principal and Dean of MCT Rajiv Gandhi Institute of Technology.
Next we have the Ramaswamy Cup, which is going to Shri Vasudev Rao VN, Assistant General Manager, HMT Watch Factory, Bangalore. Sir is a professionally qualified engineer with over 2 decades of experience in industrial engineering, research and development. Next we have the H.K. Firodia Award, which is being presented to Dr. Dhananjay R. Dolas, Associate Professor in Mechanical Engineering, MGM Jawaharlal Nehru Engineering College, Aurangabad. Congratulations, sir. Next, we'll move to Devi Thadani Award. So this is being presented to Commander M.S. Shrikant. Sir, please. A postgraduate in mechanical engineering and a veteran of the Indian Navy, commissioned in 1978. So he serves as a technical advisor to industries in the aerospace and defense sectors. Congratulations, sir. Next, we have P.V. Ramarao Memorial Award, which is being presented to Shri Yogesh S. Deepnaik, Director, DPW Industries Private Limited, Sturdy Engineer India Private Limited, and partner at Dolphin & Co. Mumbai. Sir is also the Secretary of IIIE National Council. He has more than 3 decades of industrial experience. The next is the Dr. S.R. Golapudi Award, which is being given to Dr. Santosh B. Rane, Associate Professor, Sardar Patel College of Engineering, Mumbai. Sir has more than 33 years of research, teaching and research experience, and has delivered many talks in expert sessions. Congratulations, sir. Another award under this category, Dr. S.R. Golapudi Award category, goes to Dr. Shailaja V.N., Professor and Head, Department of Industrial Engineering and Management, BMS College of Engineering, Bangalore. Next, we have Dr. J.M. Mahajan Award, which is being presented to Dr. C.K. Nagendra Gupta, Professor, Industrial Engineering and Management Department, RV College of Engineering, Bangalore. Sir has more than 30 years of academic and research experience in supply chain management. Another award under this category, Dr. J.M. Mahajan Award, we have this is being presented to Dr. Rama Amanathamurthy, Associate Dean, Placement and Training, Associate Professor, Department of Industrial Engineering and Management, RV College of Engineering, Bangalore. The next category is Coal India Productivity Award for Individuals, which is being presented to Shri Boja Ravi, Head of Management Services Department, Singarani Collieries Company Limited, Hyderabad. Sir has significantly contributed to manpower planning, wage incentive schemes, work studies, and MIS across SCCL units. Next is the Coal India Productivity Award for Organizations, which is being presented to NCL. So it is own subsidiary of Coal India Limited under the Ministry of Coal, Government of India. It is a Miniratna company since 2007. Representatives from NCL, please come forward. Congratulations, sir. Next, we have H.N. Thadani Award for Organizations, and this is being presented to Forbes Marshall Private Limited, Pune. I would request representatives from Forbes Marshall to please come onto the stage. It is a leading provider of energy conservation and automation solutions for the process industry. So they are working for over 78 years now, and they have provided innovative solutions. Congratulations to the team. Now we'll move forward to the chapter awards. Every year, two category of chapter awards are given. One is Krish Penatha Shield and other is R.S. Murthy Award. So under Krish Penatha Shield, Odisha chapter is receiving this award. So I would request Soumyadarshan Mohanty sir to please come onto the stage and receive this. R.S. Murthy Award is being given to Trivandrum chapter. Congratulations to the team. Next, we have Chairman's Award for the year 2024-25, which is being presented to Shri Prashant A., Executive Administration, IIIE, Mumbai. He joined IIIE in 1996 and has rendered nearly 3 decades of dedicated service. So he has previously received proficiency awards twice in 2014 and 15. Next, we'll move on to the fellowship category, which is a category of membership, and it is the highest grade of membership in IIIE. So this year, we have the fellowships are being given to the following names, which I'll be calling one by one. Shri Binilal P. First is Shri Binilal P., Director, Kerala State Productivity Council, Kerala. So sir has more than 30 years of experience in leading roles in production, industrial engineering, and lean manufacturing. Next fellowship is being given to Shri Rajiv Agarwal, sir, PhD, Associate Professor, Department of Mechanical Engineering, MNIT. Sir has published more than 110 research papers, and he serves as editorial board member in several international journals. Congratulations, sir. The next fellowship goes to Dr. M. Rajesh, Associate Professor, Ramaya Institute of Technology, Bangalore. Sir has a vast experience of over 25 years in engineering education, and he is an active member of Bangalore chapter. The next fellowship goes to Sri K. Chandrasekhar, Deputy General Manager, Singareni Collieries Companies Limited. The next fellowship goes to Sri So next fellowship goes to Shri Mahesh Kumar Durai, Head Initiatives Genetics Global Solution Private Limited, Coimbatore. Sir has more than 30 plus years of experience in switchgear and has worked across installation, design, and manufacturing. The next fellowship goes to Dr. Rajiv Agarwal, sir. Okay, so with this, we come to the end of the award. Sunit, sir. Okay. Okay, so the next fellowship goes to Shri Sunit Natarajan, sir. No, it's there. I thought it's there. It was not shown there. It's there. No, in the sequence, I think. Yeah, it's there. In the sequence, there somewhere it is missing. It's not in the printout, it is provided. Okay, so with this, we come to the end of the award ceremony. And one more is there. Which one? No, they have given me this. Which one? Fellowship. क्या है print out? They have given me wrong. This displays the next fellowship is Shri Mahesh Saheb Rao Bhadani sir. Next, I invite Dr. Vilas Gulabrao Dhore sir to come onto the stage and receive his fellowship. Okay, so with this, we come to the end of this award ceremony. And next year, we hope that the numbers will be multiplied with the dedication from the members of IIII. Thank you.
Thank you, Dr. Sasmita Tripathi, for coordinating this event. And congratulations to all the achievers. To conclude the inaugural session, we invite Dr. D. Bijulal, Organizing Secretary, for the vote of thanks.
Respected dignitaries on and off the dais, the chief guest of the inaugural function, Dr. V. Narayanan, Chairman ISRO, the President of IIIE National Council, Dr. A.V.V. Prasad Raju, Dr. K. Suresh, Principal, College of Engineering, Trivandrum, Engineer N. Narayana Murthy, President, IIIE Trivandrum Chapter, other distinguished guests, veterans, colleagues and participants from different parts of the country. In this session, we have seen that how the industrial engineering is helping industries as well as individuals and the society for its improvements. In the 2 days program, in the coming sessions, we will be seeing how these industrial engineering practices are helping industries through their productivity cases and how the developments are happening that helps the industries to progress in the era of Industry 4 and beyond that. I am not taking too much of time. I am happy that the dignitaries and all the guests witnessed a wonderful historical talk given by the chief guest, Dr. V. Narayanan. On behalf of the organizing committee, IIIE Trivandrum chapter, and all of us present in this venue, I propose a heartfelt gratitude to Dr. V. Narayanan, Chairman ISRO. Dr. A.V. Prasad Raju, the Chairman of IIIE National Council and President of this function, is instrumental in making this event to such an extent that at every point of planning of this function and the event as a total, he was involved, and his guidance and encouragement has made this event a grand success here. I propose heartfelt gratitude of the organizing committee and as an individual and all of us present here in this hall to Dr. A.V. Prasad Raju. Thank you, sir. For the conduct of this 2 days program, College of Engineering Trivandrum, CET, is playing a vital role by providing technical expertise and student volunteers from different departments. Dr. K. Suresh, the principal of CET, who is present here, has given an overview of how this Industry 5.0 is going to help and what are the points to be noted while developing the technologies. On behalf of the organizing committee, IIII Trivandrum chapter, and all of us present here, I propose a heartfelt gratitude to Dr. K. Suresh. Thank you, sir. The leading light of the Trivandrum chapter of IIIE is our President, Engineer N. Narayanamurthy. He is the chairman of Keltron. His encouragement is actually valuable for the conduct of the activities of the chapter. On behalf of the organizing committee and all of us present here, I propose heartfelt gratitude to Dr. N. Narayanamurthy. Thank you, sir. The chapter activities are guided by the chapter chairman, Dr. B. Anil, who is the leading light in all these events and the backbone of all the activities happening under the 67th annual convention of IIIE at Trivandrum. On behalf of the organizing committee and all of us present here, I propose heartfelt gratitude to Dr. B. Anil. Definitely, without the participants and the sponsors, this program could not have realized in these 2 days. The participants of different events, the conference, the productivity contest, and the sponsors of events, and the media persons, on behalf of the organizing committee and IIIE Trivandrum chapter, I propose our sincere gratitude to all participants gathered here, all media persons, all sponsors of this event, and definitely the team in the hotel and those who are providing all the technical supports here. Thank you, one and all. Jai Hind.
Thank you, sir. With that, we wrap up the inaugural ceremony. We thank all our guests, speakers, participants. Stay with us for the technical sessions that follow. So we have our online paper presentations that is going to happen. And the online presentation would be starting on 12 o'clock. That is on McCarthy Hall, boardroom. At 1:45, we have the productivity case study presentation on the Sapphire Hall. And 2 o'clock at the Garnet Hall, the paper presentation, offline presentation will be starting. Thank you all. National anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
also was a senior scientist in Vikram Sarabhai's Space Center. Later, he took VRS and started this company for the 20 years before. And presently, this is a company, a subsidiary of Alpha Design Technologies, which is owned by the Adani Group. So it is a small subsidiary of Adani Defense and Space. We are indirectly reporting to Adani Defense and Space. And this, I will just explain what are all the technical things we have indigenized or rather made in our office, which is a very critical item used in the cryo tank. Basically the propellant acquisition system, both liquid oxygen tank, which is used in the liquid oxygen tank and liquid hydrogen tank, it is basically a surface tension device. So this particular tank is placed inside the bigger liquid oxygen tank or liquid hydrogen tank, where from that particular main tank, it has to be passed through a system of filters, and where we use the technology of the surface tension. So I will come in detail. The basic physics what we are using, this is the surface tension of the liquid, what we have studied in the earlier school days or college days. So with that surface tension principle only, this with the surface tension, with the capillary action, and then the liquid oxygen draws from the hemisphere and pumps from the main tank to the turbo pump and then to the engine and so on. So I'm not going into the more technical details of the design or aspects of that tank. Basically there are the LOX-Pass net separators undergo various acceptance tests prior to the usage. Actually, if you can see, it is just like a spherical ball. It is having two hemispheres, lower hemispheres and upper hemispheres, and the overall size of the tank is 905 by 606 and 606 mm. The materials we are using is the exotic AA2219, which is a copper-based aluminum alloy, and the basic thickness is 3 mm. And the main sub-assemblies are 2 numbers, and total components are 50 numbers are there in this particular. The number of well joints in this particular item is around 10 numbers of wells are there. The maximum diameter is 600 mm for this, and the compact spherical separator supports the uniform stress distribution under pressure and minimizes the surface area of insulation. It have inlet port and outlet port and fill and drain ports. Internal components are as I told, to work with the surface tension, we have a filter assemblies are there. The upper net separator and lower net separators are there. The upper net letter will have a wire mesh of the 220 micron. The pore size of that hole size of the filter is 220 micron. The lower net separator, it is a laminated sandwich, where the middle of that it is the 70 micron sandwiched by 240 microns on both the sides. And it has been put up in that black shaped cone. What you can see in the filter assembly, bottom and top, that is lower hemisphere and upper hemisphere, have 2 filters are there, through which the liquid oxygen from the main tank passes through that. You can see the assembly of this is the main the bigger tank of the cryo tank. This particular propellant acquisition system, what we have seen, is fixed inside the cryo tank. From the main tank, it takes the liquid oxygen and filters it. Because why filters is filtering process is it should not get. There are 2 things. The liquid oxygen should not become vapor, and vapor ingestion should not happen to the engine or the turbo pump. Vapor ingestion should not happen. So that is the cleaning of the or the particulation of the liquid oxygen. That basically the cleaning of the liquid oxygen from the particles, as well as the vapor ingestion should not happen. So these two functions are there basically. Otherwise, our engine or the turbofan will get clogged during the functioning of the rocket. So this particular filters is the main important factor of that. The selection of the filter, the design of the filter, and the material of the filter, material of the tank, and the construction is, and the testing of the filter assembly. See, the filters has to work in a differential pressure. The differential pressure during the manufacturing of that, the filter assembly should not, filter itself should not be clogged. Filter should not be clogged. During the manufacturing process, the sandwiching of the filter should not make, the size of the filter size should not come down, or the pores of the filter should not come down. So we may have to take utmost care in the manufacturing process, as well as the welding of the joining of these two hemispheres. We have to take atmosphere. The welding we have to do at a class 1 category. The NDT has to be carried out, X-ray has to be carried out, and it has to be tested to a pressure of 3 bar. In a cyclic pressure, we have to test and use it that. So this is the configuration of the net separator assembly. You can see that the cone-shaped metallic structure, which is made out of aluminum alloy A2219, and this we have used the piercing tools to make the slots through which the liquid oxygen should come out, and below that the filter assembly, what we have told, the filters initially has to be formed, then it has to be fitted inside the cone. The cone is, the two cones, upper cone and bottom cone is a supporting structure of that filter assembly, and the basic function is what we have saying is this particular sandwiching, this particular portion of the while doing the crimping operation, the gap after the crimping should be less than 50 micron. There should not be any leakage from that side. And when the two things in the normal atmospheric condition only we are checking, and later it has to work in the negative temperature also. LOX is working as a negative temperature, maybe minus 173 also. So in the materials, the filter assembly should be compatible in the negative temperature also. The material selection is like that. So the manufacturing process, while doing this particular assembly, the gap at the swage joints, 50 micron, less than 50 micron, we have to establish in the manufacturing process. If it is not that, the bubble point, the differential pressure of this filter assembly may change. So once during the bubble point testing of this particular filter assembly, if it is more than the specified level, then this filter assembly cannot be used. We cannot use in the propellant acquisition system. So the manufacturing process is so important for this propellant acquisition system. Otherwise, there can be a failure. So this is the basic. It has been divided into two hemispheres: lower hemisphere and upper hemispheres. It will be joined through the TIG welding and electron beam welding here. Why we are using electron beam welding? There are different metals are there. Bimetallic adapters of SS and aluminum is there. The basic, the feed lines are made out of aluminum alloy tubes and elbows. So it has to be joined with the bimetallic adapter, which is aluminum and SS. So I'm not going into I think almost this, in the process, the major process, what we are doing is the machining, press forming, heat treatment, and it will be, all will be passing through the NDT as well as the fluorescent penetrant test. Generally, it will be doing the dye penetration test, but particular this, in order to find out the crack of the material or the surface crack, we are doing a fluorescent penetrant test, which is one step above the DP test. And the basic thing, as I told earlier, the filters has to be clean to a higher class level. And it is called class 3 level. The number of particles, it will be less than 10 microns. We have to maintain that filter. The filter, once you produce that, it has to be cleaned ultrasonically, clear to a level of class 3. And subassembly cleaning also will be done. And the upper and lower hemisphere, as I told, it has been the process in which the upper hemisphere and lower hemisphere is made by through the forming. Another challenging operation in this particular process is chemical milling. See, chemical milling is used for the reduction of the thickness. The basic thickness of the dome is 3 mm, but wherever the to have a reduction in the thickness or the weight advantage, we have to reduce the thickness from 3 mm to 1.5. So where we use the chemical milling. The chemical milling, we are putting this particular dome dipped into a solution of sodium hydroxide and sodium gluconate and sodium sulfide, and it will be heated to a temperature of maximum to a temperature of 70 to 90 degrees centigrade. And as you have studied in the chemistry earlier, the rate of heating, based on the rate of heating and the concentration of the solution, the thickness will be reduced from 3 mm to 1.5 mm. And wherever you want to reduce the thickness, it will be open to the surface, open to the chemical. The remaining area will be masked. So if you kindly see that, if this is the shape we want it that, and this particular area it is 3 mm, this particular area it is 1.5 mm. Wherever we don't want to reduce the thickness, it will be covered with anything which is not reactive to the sodium hydroxide. Basically, we are using neoprene. The yellow surface, it is masked with neoprene. So, next. So initially, we will be getting the aluminum alloy 2219. It is a copper-based alloy, and this will be formed in the cold condition, in the annealed condition, T0 condition. It will be annealed condition, T0 condition. It will be formed. You can see that we are using a 3 mm. You can see that from the top to bottom, due to the pressure and change in the material is getting yielded from 2.98 to 3.5. So the material which is having a thickness of 3 mm, in the bottom it has been become to 3.5. Next. And you know that the feed lines has to be made, has to be connected to the dome. So you have to flare the material. The flaring activity we are doing in the mechanical, in the annealed condition only. Okay, next. Later this particular dome will be converted into, it will be solutionized and aged, because the final welding will be done at a condition of T6 condition. That is an aged condition. It has to be joined in the T6 condition, not in the annealed condition. So as we have seen that in the filter assembly, where the liquid oxygen has to pass, we have made some windows on that cone area. The cones, that windows are made by the piercing tools. The design of piercing tool and its usage is we are doing with the pungent die with a less than 50 micron clearance. So this is also proving out of the piercing tool for windowing is also, and its design also very complex on that. Making that piercing tool also is not that easy, because we are putting the windows on a cone, not on the flat surface. We are making the windows on the cone. Okay, next. This is the sequence by which the domes are made and the welding is done. Here, as I told earlier, the SS to SS, and there is a electron beam welding also is there. The electron beam welding, what we are using, since the thickness is very high, and we don't want to have any repair on the particular line, so we are using the electron beam welding on that. And this is the well joined where the lower hemisphere and upper hemisphere are joined, particularly on this cell. There is a backup is given on that. So that backup, generally any welding requires a backup, but in this particular product we cannot put the backup and take it out. So the design itself, there is a backup which is already put inside the product. So this is the backup is a part of the product it has come, because we cannot remove that backup. For any welding there is a backup is required. So the backup has become a part of that product, design product. Yeah. So the once this ultrasonically the size of our bath is 1200 by 1100 by 700, and the as I told, the cleanliness has to be done. The allowed particles of size is 38 to 70 micron, 11 numbers. Allowed number of particles is greater than 70 micron is less. After the cleaning of the filters, the particle size is greater than 70. We have to ensure it. We have to take that liquid and put into a particle counter and see that, and it has to be passed through the acceptance of class 3 level. As I told, all the filters has to be tested, and where, as I told earlier, the surface tension principle is only applying. There is a differential pressure. That differential pressure should cross the surface tension of that liquid which comes on the surface of that the filters. So this where we are doing the bubble point test. So the test is using a GN2, the gas nitrogen, and with a flow rate of 0.5 to 0.1 liters per second. Earlier it has been doing at Mahendragiri, but it has been established in our facility Trivandrum, and with the flow rate control and all we are using. Then this will be as in our lab. Everybody might have studied that rho GH is the principle of that pressure, and the differential pressure will be calculated. If that differential pressure is less than 20 millibar, only the product will be accepted. Next slide. The upper net later, what we observed, we got that value from 13.1 to 10.1 for the upper and lower net separator. Filter unit also. So the specification is 6.6 to 20 millibar. Suppose if I am getting a value of 21 millibar as during the bubble point test, the product will not be accepted. It has to be throw it. So further we cannot take it any component from that assembly and use it also. So the acceptance of the particular net separator level is the LN2. And then particularly this particular product has to be put into LN2, that is liquid nitrogen. We have to immerse in for 1 hour and see that 50 micron gap is there and no cracks are there. The material used, the aluminum is intact, filters are intact, SS filters are intact, that we have to establish. And then it will be subjected to hot nitrogen purging at 50 degrees centigrade. It will be dried in thermovacuum furnace. Next. And initially when you develop a product, we have to do the flow calibration. Flow calibration of the particular, instead of liquid oxygen, we are doing with the DM water. So based on the design data, these values are within that range, and it has been done at IPRC Mahendragiri. It's a ISRO unit and it has been accepted also. The liquid, we have been doing the pressure test of this particular log spas in 2 different ways. Upper and lower, we make it separately, and then it will be together, will be fixed and test for a 3 bar. Why we are doing that? Before close welding we are doing again, because if you have any problem or any leakage in any one of the sub-assembly, the other sub-assembly can be salvaged or it can be rectified. So, you know, in order to remove that rejection clauses, rejection or the loss of the product, so we are doing in the half level effort, we are joining with the fixture and doing for a pressure test as 3 bar. Once it is successful, only the lower and upper will be joined, and it will be further will be tested to cyclic like this from 1 bar, 2 bar and 3, and MEOP of 3.3 bar it will be tested, and it will be, once it is tested, it will be intact and purged with the nitrogen, and it will be used and sent to the ISRO. Yeah. So the remaining, there are the liquid hydrogen tank propellant acquisition. The method of filters is the same, only the design, there is a bell mouth design they have adopted on that, not only for the liquid oxygen propellant acquisition system, only they have adopted the spherical shape. The other one all are bell mouth shaped only, they have taken it. The filter assembly and the testing of the filters is same as that of the LOX pass itself. We'll just go through that. I'm not going to explain much detail on that because it is the same typical one, only the design is bell mouth. Yeah. So these are the realization, some of the realization photos what we are making it inside the plant. This is a bubble point test setup. Yeah. Yeah. Next. Then next is the C25. Yeah. Next. These also, as I told, these are all the assembly. This is only the, instead of conical, it is a flat assembly. But the shape of this is a bell mouth. Yeah, next. Yeah. See, all the assembly is the filter assembly is basically our physics surface tension with that principle only works. It breaks, and then by the capillary action it sucks that liquid oxygen from the lower to the higher, and then passes to the turbo pump and then engine and so on. So it has been this is being used in both GSLV Mark II, and whatever we produce is being used in GSLV Mark II and Mark III. Yeah. Beautiful. Thank you for the patient hearing. Yeah. Any questions or not? Right now it is all indigenous material. Earlier the mesh, the SS mesh was imported. Very recent batch it is indigenous from Hyderabad. Yeah, thank you.
So we are about to start the next technical session. So we have Mr. P.H. Kurian IAS. He is a postgraduate in chemistry from University of Kerala. While pursuing his PhD in organic chemistry from Indian Institute of Science, Bangalore, he joined Indian Administrative Service in 1986. He served in various capacities in the professional government of Orissa and Kerala. He joined as a Controller of General of Patents, Designs, Trademarks, and Government of India on 22nd January 2009. So he has wide experience in entrepreneurship development, labor relations, industrial financing, and policy making at professional government level. Welcome, sir.
Good morning to you all. Esteemed members of the Indian Institute of Industrial Engineering, distinguished delegates, industry leaders, researchers, faculty members, and all friends, ladies and gentlemen, who were in this program. It gives me immense pleasure to be here at the 67th National Convention and the 9th International Conference of the Indian Institute of Industrial Engineers, a platform that brings together some of the brightest minds in the engineering, innovation, and sustainability. Now we talk about Industry 5 and sustainability, AI-driven industrial engineering and sustainability is a great topic. I don't know how the organizers have found me eligible to speak on a technical subject. My knowledge of engineering is almost zero, but I have experience in the public realm in different departments. I thought about that, and while accepting, I thought I should not speak much about the technology of Industry 5. AI, I only know very little about AI or reading abilities and, let us say, seeing ChatGPT and things like that. That's all knowledge I have about AI. Use of AI in engineering, in production, manufacture, my knowledge is zero. So I should not speak about anything. You have plenty of sessions after this, and you have a lot of experts to speak on that thing. So I only thought that how this is going to, how important is sustainability in Industry 5. That is all I thought I should speak about. Now, Industry 1, Industry 2 time, for example, when mass production started, there were a lot of social issues at that time. All the regulations on industry came after, by the middle of the Industry 2 period. Look at all the labor laws came. There was no labor laws in Britain. Britain and its colonies. India got a labor law. First labor law comes only in 1948. The what you call Factories Act and that type of thing came. So people had to suffer a lot. So all the regulations came much. So the history of industrial advancement or modernity, modern systems and all that shows us that we have to be very careful while we enter into most disruptive phase of the industrial progress, which is Industry 5, automation, AI automation. When it comes, there will be a lot of disruptions. Of people like that Yuval Harari has mentioned that there won't be any jobs. All people will be sitting idle. There will be universal basic income. Government will tax the computers who do this, or the person behind that computer, or the company behind that computer, take a lot of money and give to people who are sitting idle. This type of a doomsday prediction has been done around 10 years back. So there is a lot of fear among public that if all AI automation happens, what is going to happen to majority of public? The community as a whole will not be benefiting. Coupled with that, the corporate running for profits. Every CEO's responsibility is that maximizing profit for the shareholders' value or maximizing shareholders' value, increasing profit alone. Now this is a good opportunity you introduce as much automation as possible, you get more money. But he is not thinking who is going to buy that. All his industrial output, there should be somebody to buy. He can't himself eat or consume or use the machines which he produces, or any product that he makes cannot be consumed by himself. That is where all this concept of thing came, where you had a given idea when it was up to Industry 4, that it was all managed. Now if you pursue recklessly with the AI and robots, what is going to be for the public? That is the concern for sustainability came. And in all global forum now, that is a given thing, that you have to plan everything in Industry 5 with sustainability in mind. In this phase of industrial progress, we have to have sustainability in mind. In, let us say, Industry 3, Kerala, when computer came, Kerala people opposed computer, saying, take away job. They were not made ready by the stakeholders at that time, that this computer will enhance productivity, it will reduce your drudgery, more jobs will get generated elsewhere. If your job is lost, you get a job elsewhere, we will reskill you, and then nobody said that. Nobody anticipated in that way, and everybody went with the reaction, with the result that Kerala lost all those initial advancement in that Industry 3. We lost because of that. So I think globally, now communities, public, policy makers are very much aware that if you go like this, this will have a disaster consequence from the people point of view. The other point is on environment. Other point is for environment. So people, planet, and profit, not the other way. First you make profit, then you look for planet or people. It needs to be reversed now. That is the thing which each one of you have to keep in mind. That is the only way you can also progress. Otherwise you produce the whole thing. So the whole concept of industrial production, as industrial engineers, you have to plan. While using this, you have to plan this also in mind. This is all what simply I understood by this, and that is very much example. I use the whole thing like this. So the regulations came much later, which was disruptive to the industry. We have seen that. All sorts of regulations you put on industry while they are progressing, which is disrupting the industry. It will reduce their profit. If you plan these regulations in advance, that is what the governments of the day need to do. Now, I have seen the artificial intelligence, robotic and all that of the Karnataka policy. They never speak about this aspect. Karnataka government has a very detailed policy. Tamil Nadu government has a policy. Kerala also has a policy in 2022. Very little is spoken about this. It's spoken about equity, that all has to be educated. So Kerala also started AI education in the school itself. That's one part. That is again of the sustainability part. There should be equity. All people should not be left behind. Equity should be there. All that plan, what government needs to be doing in a small way. States have also started, countries have started. But what about countries like Africa, if you think globally? I don't know when AI education is going to start in African countries or those small countries. So when globally you think, a lot of that efforts needs to be done. Now, I read what ILO is planning. ILO also brought out a lot of paper guidelines in 22-23 that this should not happen, this should not happen, this is the way industry should behave. So certain guidelines have come. So based on that, the regulators have to now plan and bring in balanced regulation, not disrupting the progress. See, the regulation which you made in 1948 called Factories Act still remains on the statute book. Today's industry, it is very disruptive. Nobody can accept those regulations now at today's level of progress. Today's level of technology, many of those regulations are unenforceable. Unenforceable provisions are still there in many of the regulations. When this comes, the regulation has to change. So if you have to be sustainable, then the regulations have to be planned in advance. So one of the things is this, the regulators, that is the government, policy makers, the community, or the, now we call the civil society, and the industry has to come together and plan this in advance. This is not together alone, but each one of you in your environment when you plan for this or when you have already done it, you need to integrate that aspect also into your technology progress. You reuse material, you reduce waste. So everything that you do now, but integrate all that into the overall concept. That's what I understood. That is what I call upon you to think about that thing. If interact with the government, that these are not delayed, these regulations are not delayed. Another aspect of AI, when it comes, it consumes a lot of energy, and then you say you will go for renewable energy to have sustainability, but renewable energy itself is polluting. Renewable energy itself is polluting. All those rare earth minerals, I found that in China or something, they do very destructive mining process. Solution is there also AI. AI can be used in mining to have less destruction. So nobody is planning in that way. I go ahead with my AI. But the AI is required in some other area so that the whole thing is not disrupted in future. Then look at governments coming together, the geopolitics, how is getting affected. We know China, America, India coming, fighting for these materials. All this at an international level, people have to come together and plan. Otherwise, on one side this will happen, there could be a possibility of disruption in between. So there are a lot of policy issues which needs to be considered when you introduce this technology for the gains of not only the companies, gains for the whole society. So one part of it cannot be ignored. The environment we see every day. I was for a year and a half environment secretary in Kerala. Same time I was disaster management secretary. We had a big flood. Nobody could predict what it is. There we used AI. For relief and rescue, we used AI. There were some engineers with us. There is a company, I forgot the name. Some few girls sat together, did a lot of AI work and tried to pinpoint where the people are stranded. We could find and send a helicopter and then fetch those people. The AI was used for relief. AI can be used everywhere. So I found that when that type of thing happens, there also AI can be used. So for every area, the Industry 5, the technologies will be together will be used, but this aspect has to be kept in mind. So I thought that that is my policy. I think my role here should be speak about very intentionally on that part of it, while maintaining the physical environment, but the social environment together. Then only we can have a sustainable progress for the society as a whole. I personally don't believe what Harari has predicted. Everybody will be sitting idle. I see, just simply watch, and my 60 years of memory, I'm 66 years old, 60 years old, I see, where something is lost, something else has come. No doubt regarding that, and human history always shows that, right? Now, if you get more money, look at the way number of tourists increasing in India. When people have more disposable income, they travel, they leisure, they consume more of healthcare industry will flourish, so jobs will be elsewhere. So if you're in your factory, in your environment, if there is some job lost, now it is you and the government together needs to reskill those people. I don't know how many people are planned it. Many of your subjects, I saw very little that plan subject is not there. They're all technology only. I don't blame because your technology is sitting. But I thought my job is to remind you that while doing this, unless you plan it will be in your own loss if you don't do this. So otherwise there will be heavy resistance like the resistance for computers in Kerala. Now you can plan. AI is not made. Those days computer was not known to people, so they refused. Now this is to be made known to the people so that initially they won't disrupt the progress. So that part of it has to be planned together, the environment and people. So that is why we say the planet, people, planet and profit. So if you simply make profit, it's not sustainable. It's not sustainable. If the temperature goes like this, the emissions goes like this, and you have everyday problem, not always in not always in Uttarakashi. It can be in Kerala, it can be in Karnataka, it can be anywhere. These mass floods and landslides and things like that happen anywhere. So one has to keep mind saying that we will not destroy the environment. That is a common subject. But when you as engineers, industrial engineers plan introducing AI and all these disruptive technologies into this, please keep in mind these aspects. That's why Industry 5 is going with sustainability. This is what I understood. I think I appreciate the Indian Institute of Industrial Enterprises, industrial engineers to have planned such a thing, and this should continue. I think this is annually once. Maybe you should have the actual players a separate thing to discuss about this. India always talk about all this, but practically we have seen very few examples. I have gone through the literature and find that there are people who have introduced this technology and made a lot of gains. Resource efficiency, less material use, environmental management, all has been done. But how much of it has been passed on to the community? While reading those examples, I have not found much. So one has to be very sensitive about that thing. You have to carry people along with that. The labor's rights has been redefined by the ILO. In such an environment, you imagine there is one, Narayana Murthy says that 70 years you work. In 70 hours a week you work. In France, people go on strike, signing reduced to 4-day work. They want to reduce from 40 to 32. Now in future, 40 will come up 32. Otherwise there won't be anybody. So let people enjoy more that thing. This is what is sustainable. And also human ingenuity is such that this also together they control the population also. Who is having more than one child? In this environment, I don't think anybody, a lot of people will abstain from producing a child. In Industry 5 time, another maybe 10 years, 15 years time, you will see so many people will not have a children. I went to Japan. There's a company called Nicha Jalati in India Limited. Headquarters, I went there. So one engineer who was me and my wife, an engineer and his wife, he has taken us for a dinner. He has followed us everywhere. Okay. So I asked him how many children. He has only one child. I think very rarely I couldn't imagine that somebody is speaking like, he says, I cannot manage more, I cannot nurture more than one child. He said, I had to send my son for, everybody now, my children are going to America for engineering, send my son for American engineering. We planned at that time. We cannot send more than one child to America for engineering. We wanted only one. So in maybe after 10 years, even that one won't be there. So human ingenuity will such that they balance. So doomsday predictors like Harari or something, just I dismiss all of them in personal. By reading history, he is a historian himself. He says everything will go. We need not bother such man. I live in a country like India with today 140 crores of people. When this comes, and if you behave properly, and with responsibility like this, if you go, we will have a great progress. We will bring more of AI into our operations, produce more efficiently, with responsibility, and we can flourish together. That's all. I thank you. I was given half an hour. I don't have anything to speak for long. I can speak about with my experience or something. I don't want to bore you with that experience relating to this. Relating to this. Thank you very much.
Thank you, sir. Thank you for those insightful words. So now I welcome Dr. B. Anil for handing over the token of gratitude.
Sorry. If some questions are there, please. If some questions are there, definitely it's welcome. Know your view on that. Last week I was thinking about TCS retrenching
12,000 people, yes.
It would be the casualty of Industry 4.0. Because Industry 5.0, we talk about people. So there, the automations made 12,000 people lose their job.
when people-centric means, you see, there are 4 dimensions of people existence. People say the physical skill, intelligence, wisdom. And intelligence, up to intelligence now, I think
partly taken over by that.
AI can take over. But the wisdom part, AI cannot take over. So is it the exact application of 5.0, does it mean that the room for exercising wisdom part,
it will never go.
That still has to be honed by the people?
Yeah, it will not go.
That
now, TCS has taken, I think, 2-3 lakhs people they recruited in last 5 years. Maybe it became excess, not because of the entire coding has taken over by AI or something. Maybe they had an excess. It may be their HR failure. But at the same time, Infosys is taking more people this year than last year. So TCS may take next year. This is an industry, it happens actually. It comes and,
maybe the younger generation should hone that skill now to go towards industry 5.0.
That is why I said that reskilling not necessarily in the same domain. How many, I think any one of you know how many people left IT, coding, and went to other sectors. They can have a tour company. A coder can come out and start a tour company. Why not? It will be more income for him. Should be his lifelong, he should be coding. I don't know how many years he can code anyway. By 40, 45 years old, they all worn out people. They should come out and do this. So there is no continuity of job or something. That type of thing cannot be thought out in this disruptive time. Everybody should be prepared for changes, reskilling, and get out of that thing and do lot of job. How many people? I know a lot of people coming around using simply share market trading and earning more than that. How many people are coming out and doing it? He got skilled into that thing. He learned that thing very well. Sitting daily, trading, one day he loses, one day he makes money. I know many people who are doing that now. Not only here. Even in US, there is a friend of mine in US who was in IT industry. He does only trading now. Online trading, sitting. आराम से पैसा बनाता है. कोई problem नहीं.
Yes, sir. Regarding industrial engineering, ILO, there is a definition for qualified worker. Does it change with respect to this in the AI environment?
Definitely. That is why I said all those regulations has to be dynamic. In industry 2-3 times, your regulations were unnecessarily strict. I was labor commissioner for long in Kerala. And so many of those regulations were not dynamic enough. Recently also you heard in Kerala, in the Kitex factory, the earthen pot has to be kept for water. It is put in the rule, nobody changed it. So ILO now at least reacted in 22 by changing qualified workers, quality, all that thing has come in. But that also should not be strict like the earlier colonialist made law. In that mindset, I don't blame the people who were there. See, if you industrially speak, if that regulations were not there, a lot of industrial progress would have happened in Kerala. All those, in India as a whole. Factories Act 1980 has a big burden on industrial progress. And people have not, changed it over time. When I was in 2 years' time, there was something called Plantation Labor Act. No change has been done even today. All the plantations got suffered because of an antiquated labor law. Today is a case where there is no labor is available for plantations in Kerala. Still you have to have all this. Around that place, plantation was in remote place. So in 1948 plantation, 1950 Plantation Labor Law Act had a provisions to start a hospital or a dispensary and everything. Today just outside your thing there is everything and almost all the workers have vehicle now. He can go and avail that. But still says that you have to have a doctor, you have to have a nurse, you have to have a pharmacist. All that thing still remains in that. I see every day such a thing. Now, when these three comes, the regulations have also to be framed in a dynamic fashion so that it can be changed from time to time easily. India is one country where you legislate forever. America, a lot of days they have a limitation. This law is made for 40 years. After 40 years, automatically goes. So India should make now laws with, except let us say some crime or something like that, these type of laws have to be made for a period of 10 years. If 10 years, You rework, and then what is necessary at that time we made, the rest of things should go. That concept has not come into lawmaking. So these disruptions will make us to think like this. We know now the recent history of last 100 years or so, how things went bad, how we could have avoided that. Enough learning. Now AI will give you all that learning in 1 minute time. AI again is a solution. It's a circular thing. All your problems can also be solved by AI. Thank you.
Yes, sir. Sir, another aspect is boiler rules. Boiler rule is everything is automated. No, there is no point.
Thank you.
Mr. Kurian, one more question for you.
Please. Yes, Rajiv.
You had this illustrious career in intellectual property, right? Yeah. Can you say something about IPR aspects of AI-driven industrial engineering, if you have thought about that?
That again will take time, I think. See, IPR regime, as brought in the TRIPS agreement, is there to stay. It's very difficult to dilute it. Now, my opinion is, I think you can all think of, when the advanced nations came to WTO agreement, allowing other countries to trade freely, they knew it at that time, that countries like China, India will cheap produce and sell more in developed countries, and they become rich. What was their thing was, there was their brain, their IP. So they wanted to protect that IP so that these goods which are produced will be bought by them, but you will buy their IP product and pay them. This was what is WTO. In my simple example, IP, the TRIPS agreement was signed along with WTO for that purpose. That still continues. That still continues. So it won't be that easy. They won't agree in an international relation to dilute the TRIPS law anyway to help these people. When I use that compulsory license thing, today, now we find that compulsory license should have been better. In India, after I issued the compulsory license, to be very frank, I was a person who is following this, I issued the compulsory license reducing the price of an agricultural product from 2,84,000 to 8,000. Okay, Indian production cost, compulsory license, the patent has gone to dogs. Patent has gone to dogs. Now what our drug companies used that, they used as a weapon. This is what I find coming 2-3 years. Not to again ask for compulsory license. They threaten the IP owning MNCs of the West, saying that we will ask for a compulsory license, screw you up. Otherwise what you do is, our generic drugs, you sell there, your drugs we will sell here. So they all entered into that type of agreement. So these are very, very intricate things. It's not as simple as the ordinary main thing. The people with brain know how to use it. So suppose in the Indian, now this trade war thing, how do you issue 2-3 compulsory terms should have come down? It's a big weapon. We are not able to use it. After the BJP came to power, they give a return directive. It is not the government, it is the controller as a person, he is a quasi-judicial story, he does this. They said, you see, President Jayashankar, I went in 2014 November, he was our US ambassador. So we went to New York, where he hosted a dinner. In his speech says that these are only IAS officers of 86 batch. He said, one IAS officer who issued a compulsory is the biggest headache for me now. US-India Business Forum, all the problems in all my diplomatic issues are now based on that officer. Then somebody said that officer is sitting here. I stood up. This man, Bagga, Ajay Bagga. Ajay Bagga was taking a class for us in Columbia University. He was saying that one IAS officer has screwed my life. I am US-India Business Forum. What is that? US-India Business Council. I was the president, and this Indian fellow has created a lot of problems. At the time, tea time, somebody said, he says, Kurian sir, privately I salute you, but as chairman of US-India Business Council, I have to condemn you. So these are, IPR is a very, very touchy subject. Unless
do you think we'll be able to create a lot more IPR these days with AI.
India is also going. China, you know how much it is now annually? 15 million, 1.5 million patents per year. 1.5 million patents per year. They are little diluted, quality diluted.
Fake
But
patents.
still, let us say, instead of that 1.5 million, 0.5 million commercially viable patents are there. What is going to be their progress? We have reached a lakh now, the Indian patents. When I was there, it was only 10 or 12,000. Now 10 times. In last 15 years, we have gone around 10 times of that. Ours also, we still maintain quality much better. But that is not the progress that we require.
Not enough.
Not enough. Then these are the things I said. When we made a law in 2005, there is a provision called 3K,
3K, right.
on the software.
Right.
Now, if the AIs are to be patented, there has to be a big thing is going on now. Now, the industries have to say that this is our intellectual product. We need protection. So, India has a very unnecessary strict provision. That's what I said. You make regulations which are forever.
The 3K is being diluted now, though. The
Let
new
it be
CRI.
diluted.
Yeah.
Let it be, with the time it is to change. Not diluted. Nothing is changed in the law. Diluted is only by that. I follow that very clearly. The CGPDTM has issued some guideline, which some people say it is a guideline. It is a little more of IPR enabling. That's what I say. It's not better. The word remains same. Wording has not been changed. Not diluted in law. Some sort of an amendment need to come in that thing. That is why I said regulations should not be forever. With time it changes. If it is beneficial to your country. See, Indian law, Indian that we will change law. We will change the word, which is foolish. We sitting here will change the word. We will say that we will now protest against American. Why are we sitting in Kerala? Why you protest? Be very practical, that's all. I made some notes which I made some. No. It's okay.
Now I invite Dr. Anil B for handling or the token of memento, token of appreciation to Venugopal sir. Sir, please. Thank you, sir. So now we'll move on to the next technical session. Next session is by Engineer Srikumar, Center Head Tata Elxsi and Secretary of GTEC Group. So he is a professional with several years of diverse experience in operations, customer service management, and client servicing. He has got a management experience of 33 years in various industries. So thank you, sir.
I don't know. Very good morning, rather good afternoon to all of you. At the outset, let me thank the organizers of Indian Institution of Industrial Engineers, Anil sir, and other organizers here for giving me this opportunity. I know it's a difficult time to speak. I stand between you and lunch. But I've assured Anil sir that I'll finish off in the minimum least possible time. Hence, no PowerPoints here. I represent two organizations. One is my company, Tata Elxsi, here in Trivandrum. We are the engineering arm in the Tata Group. And being in very niche areas, we are a small company. compared to our big brother TCS. When TCS has 6 lakhs people, we have about 16,000 all over the country. And in Trivandrum, we have got about 3,200 engineers working on solutions, on engineering solutions for the automotive and media domains. To make it a bit more simple, when you see the infotainment on your car, there is a Tata Lexian who has worked behind it. When there is an automotive feature, a luxury feature which is something to do with advanced driver-assisted systems or autonomous vehicles, Tata Lexi has something to do there. So we work behind some of these new age futuristic solutions that go into the automotive sector. In the media, when we watch OTT on television, there is a solution that runs in the background made by Tata Lexi. Here, let me talk more about the other organization. I represent an association called GTech, which expands to a group of technology companies. We are the IT industry body for Kerala, and on a lighter note, we call ourselves the NASCOM for Kerala. We have about 300 members in Kerala, all of them companies who make solutions in the IT and IT-enabled services. Kurian sir was IT secretary here for a long time, and we had the opportunity to get all of his support in developing the IT ecosystem for the state. I'll take this opportunity to acknowledge and appreciate the efforts that sir took in solving our problems and getting a lot of initiatives done for the IT industry here, the result of which we actually enjoy here. Today, Technopark has got about 75,000 IT engineers working, an equal number in InfoPark, and a budding cyber park in Calicut. Outside the parks too, there is a vibrant IT ecosystem. Altogether, it is creating lakhs of opportunities, employment opportunities for bright engineers here. But today, we talk about AI, which will steal all the jobs. And as some of these people who create a big hype about it, saying that we might have big job losses, people sitting idle, there will be socio-economic problems around AI, a lot of disruptions going to happen globally. From the IT industry body, we have a different opinion. This is history being repeated. We have seen such disruptions happen over all the industrial revolutions. There was the bullock cart carrying all the load, and when the truck came in, the bullock cart was not required. But if we didn't know how to drive the truck would have been a disruption. The same is going to apply for AI. I took this metaphor because in AI, we will have to train ourselves to drive AI. And if we train ourselves, then AI is going to be an opportunity. If we don't train ourselves, then for all of us who don't train, it is going to be a disruption. So that's as simple as that. The buzzword here for all young and senior technocrats who work in IT industry or in any industry today is to unlearn, relearn, and adapt. This should be the slogan, because you will have to learn continuously as long as you work. Till your last day at work, learning will have to be a part of your life. It is only by relearning, unlearning, relearning, and adapting that we will be able to handle and manage and engage with the disruption that AI is going to cause. There was a question here on the job losses at TCS. It wouldn't be appropriate for me to comment on what happened in TCS, but from whatever we know, the job losses are not because of AI coming in. That disruption is anyway going to happen in the months and years to come. But then this has happened because all of us in the IT industry overhired post-COVID. And that overhiring was not actually conducted in a structured manner. It was something like panic hiring. And we are now shedding that flab. This is happening across industry. It is only to stabilize and restructure the whole organizations to run better profitably. Coming back to GTech, quickly, I would like to mention on an initiative which GTech has been undertaking to address all these kind of disruptions and to bridge the gap between academia and industry. There is always this gap between academia and industry. It's been there universally, but on a higher scale in India and at a much higher scale in our southern region. This initiative of GTech is called MuLearn, M-U-L-E-A-R-N. This started off as an idea in one of our members. There is one member called Mr. Deepu S. Nath. He's a young entrepreneur who runs a company in Technopark, his own company in Technopark. And he had this idea to make something which will bridge the gap between industry and academia. He thought that access to knowledge, technology, and skilling should be democratized. And it should be made available for anyone, any student, any aspiring learner, free of cost, at his fingertips. So that created the idea of MuLearn. As the old thinker said, an idea can become a material force when it grips the masses. So this has gripped the masses in the IT industry and in the academia. What started about 3 years back as an idea, developed into a movement, was made into a platform. Today, without any PR around it, it's got 52,000 students in Kerala live on the platform. It's got 1,912 colleges and schools registered on the platform. 400 mentors and evaluators who evaluate the work done by students on the platform. It's got 26 interest groups which the students can come and join in. Nobody teaches anything on the platform. It is a Discord platform which enables students or any learner in any age group to come and register onto the platform and find this interest group there. If a student or a learner is interested in cybersecurity, he will definitely have an interest group there. If a student or learner has an interest in music, there is another interest group which is available there. If not available, he could create one and soon it will form an interest group. All learning happens on the platform by peer learning. And the motto of the platform is that if you learn something, you need to produce a proof of work. So when a student passes through 6 stages of the platform and comes out of the platform successful, he will definitely have a proof of work of what he has learned. So there are 2 options when he comes out. He either will get hired or he will become an entrepreneur himself, a freelancer himself. We did not envisage this when we started off, but today the success is shown. There are stages in the platform where the platform tests for students' perseverance. So if a student does not go through that stage of perseverance testing, he will drop out. It is simply testing whether this student or this learner will continue to do the same thing over a period of time. For example, the platform will ask the student to keep on typing. Today's youngsters are all experts in typing on mobile and laptops. So the student will definitely ask for himself, why is this platform asking me to type? One young smart student in one of these engineering colleges in Trivandrum typed the whole night. Next morning he gets a message from Limca Book of World Records that he's created another new world record. 2 months later, Meta conducted a contest, a global contest. They wanted a new feature for their Instagram Reels. And to compete in that contest, you needed to know something called Spark AR, which is a tool or a skill that has to be mastered to participate in that contest. MuLearn at that point of time had about 3,000 students enrolled on it. We asked them, none of them had this skill. So we asked for volunteers who can draw, who have the capability to draw. 62 students came up. All 62 students were trained on MuLearn, on Spark AR for 3 days because the contest had a deadline. After the contest, 219 winners globally, out of the 219 winners globally, 29 were from MuLearn with a cash prize of 18 lakh rupees. This is not a success story, but it is something that which reminds us that reskilling and retraining will be successful for anybody who has an aspiration to learn. This is going to be the mantra for the disruption that's going to happen because of AI. Continuously, industry professionals, irrespective of their seniority, along with juniors, will have to unlearn, relearn, and adapt to this new normal that is evolving. Today, our organization GTech has changed this MuLearn movement into a company held by GTech completely. It's a Section 8 company which will have a structured governing structure, and we hope to take this movement of MuLearn to the next levels, where any student globally, any learner, aspiring learner globally, and any professional who has got enough of experience and the capability to evaluate the students' work can join there. All of what happens in MuLearn is volunteering. There is not a single rupee transaction on the platform, and a lot of success stories are coming out of it. A lot of entrepreneurship we are seeing there. Students who are bright in their learning capabilities, in skilling themselves, are coming up with bright ideas and solutions which are turning out successful as startups. As we know, Kerala is now a startup capital of India by numbers, but still we have a long way to go, and such platforms by industry and academia coming together will definitely pave way for a brighter future in the disruptive times ahead. I don't want to take more time. Wishing the event and the organizers a grand success for this year's event, and let's hope that in the coming years too we come up with such vibrant events by the organization. Thank you all for the patient listening. Thank you.
Thank you, sir, for the insightful words. Now I welcome Dr. B. Anil. And the floor is open for Q&A.
Thanks for a very nice session. I just want to know, this initiative, does it have any association with TEDx activity? TEDx?
Currently, we do not have any association, but I think there was one session in TEDx about MuLearn, but other than that, there is no activity.
Okay, thank you.
Any more doubts or questions? Thanks. The lunch counter is now open. You can go for the lunch right now and be back by 2:15 sharp.
Good afternoon all. The session is about to commence. So we will invite our respected panel members. So this session we will be having a panel discussion and discussion on the theme Human-Centric Design in Industry 5.0, Balancing Automation and Empathy. So we have our respected panel members, Professor Rajiv Srinivasan from IIM Bangalore, Engineer P. Balakrishnan Nair, Chairman, IEI Kerala State Center. He will be serving as a moderator for today. And we also have Engineer M.C. Bhattan, Scientific Advisor to Chief Minister of Kerala. And we have the fourth panel member, Engineer K. Ajit Kumar, Executive Chairman, BPT Kerala. So today's moderator will be Engineer P. Balakrishnan Nair, Chairman, IEI Kerala State Center.
Am I audible?
Hello. Hello.
Hello? That is fine. So, good afternoon. So, our afternoon session starting with a panel discussion. And panel discussion, we have got, as mentioned, at the moment, four members are there. My name is Balakrishnan Nair, and then I got my friend Rajiv, as well as even Engineer Ajit Kumar, and Engineer Chandradattan sir has not yet come. He will be joining a bit late. So we have got the panel discussion because since it is connected with Industry 5.0, and also it is human-centric because that particular topic is connected with, the human-centric part. So we also have to be, discussing about what could be the effects, what could be the challenges, and how we may be able to mitigate on that. So that is the point of discussion. But before going on to the discussion, we'll all give a small introduction about ourselves, about what we were, what our experiences. So, and then, it will not be taking much time. And so the whole discussion is for about 1 hour. And connected with, initially I will start with myself, being the moderator. My name is Balakrishnan Nair. I'm currently the chairman, the Institution of Engineers India, Kerala State Center. And I have been working in various fields, like, Larsen & Toubro, Tata Consulting Engineers, and then again working with what you can call oil and gas industries, Petroleum Development Oman. I was at the company, company representative, and also project manager level at various organizations in Qatar. And then afterwards I came over, and then I started, again, taking up an academic position. Academic in the sense because, we have seen that oil and gas industry, they're all very much concerned about everybody. Today, everybody is concerned, but at that time, oil and industry was actually very much concerned about, the loss of lives. The loss of lives because we were all working around that area. So they made it very clear that, some health and safety, occupational safety courses need to be done, need to be qualified, in order to ensure that the safety of the personnel are met with. So I had, the fortune of getting onto an approval from the UK approved NEBOSH Examination Board. They call it as NEBOSH, National Examination Board of Occupational Safety and Health. It is just equivalent to like Kerala University and other things across over there. Qualify themselves, be a trainer over there, and I'm at the moment taking classes for NEBOSH, including the diploma level, which is equivalent to the graduate level in India and all. I'm doing it for the last more than 13 years now, and so I'm currently going ahead with visiting places, going on to the visitors industry, and I am various member of UK bodies as well as also of National Safety Council, India, and then take various sessions and all. And I have presented more than 59 papers, technical papers across the various forums, both on safety, both on technical angles. And I have chaired various sessions, being a member of the Indian Institution of Engineers. I have chaired various engineering, engineering congress sessions on technical matters. And also I have been, just a moderator for this kind of technical talks, as well as, online session presentations, and online and offline presentations in any case. So this is about myself, a small brief. And also I have to tell about myself that I am a recipient of Sir Vishwesvaraya Gold Medal Awardee. In 2019, I was awarded that in Hyderabad Indian Engineering Congress. So that also I have to tell you, and I was honored with some other kind of positions across. So in any way, I'll just hand it over with these details down to my colleague, Rajiv.
Well, that's a tough act to follow. Very impressive background you have. Let me tell you about mine. I don't belong to the manufacturing fraternity myself because I'm an electrical engineer by training, IIT Madras, and then most of my career I spent in software. So I was in the US for a long time, Bell Labs, working on Unix, and then I was in Silicon Valley for another 15 years. So after that, I came back. In the meantime, I got a master's from Stanford, an MBA from Stanford University. So I was doing a lot of business-oriented work, product management, director of marketing, VP of marketing, things like that. And then I came back to India some 27 years ago, and I've been doing a variety of things, including running an incubator for hardware companies. This is called Maker Village, that's in Cochin. I also ran a business school in Trivandrum called the Asian School of Business. But apart from that, I've been teaching at IIM Bangalore for the last 20 years. My courses are on innovation and on design thinking. So I'm a part-time faculty there. Apart from all this, I was in a panel that wrote India's first intellectual property policy. That's how I know Mr. Kurian. We spent some time talking to each other about IPR issues when he was the secretary in the Kerala government. And he was also Controller General of Patents and Trademarks at a point in the past. I'm also a columnist. I've been writing on a variety of topics for 30 years or so. And occasionally I appear on Malayalam TV as a commentator on international affairs. So that's it for me. Let me pass it on to Mr. Ajay.
Thank you very much, Rajiv. So first of all, I really congratulate or thanks Indian Institute of Industrial Engineering to have a panelist with one of among the top honors of the professionals of India and a broad experience. And Dr. Ratan Saab also joined. So first of all, I am very much thankful to you. Then coming back to my background, I was, before coming to now, I am heading the public sector units under industries called Board for Public Sector Transformation as an executive chairman. Before joining this, I was executive director in BPCL Kochi Refinery, almost having a 36 to 40 years experience in the oil industry. I have also worked in commissioning of Bina Refinery in Madhya Pradesh. Then I had been to KNPC, Kuwait National Petroleum Company, as a specialist for the turnaround inspection and strategy making. And now I am taking over of PSUs in industry, under the industries department. Around 52 industries are there. That is from almost from bamboo to electronics. That is Bamboo Corporation to Keltron. Up to that level we are dealing. We have made changes as the word stands for the transformation. We are trying to make our PSUs to be self-sustainable. That is the target. And I can proudly say that within a year of 1 or 2, we have made tremendous changes in the industrial circles and especially being the electronic industry, and I'm very much proud to say that Keltron, when we joined, it was only a 350 crore turnover company. Now it has come to 1,055 crore turnover company. So that tremendous changes it has taken place in the last 2 years, and we are also leading pioneers in the defense technologies, aerospace, and traffic management and other intelligence systems. So we can be in that. And also we were in the traditional industry where in the car sector and other things we made sweeping changes, and we entered into Walmart for the first public sector company in India to enter into Walmart. So that much changes we can take it. So today's topic is very relevant, where Industry 5 always stands with technology with the human face. So over to sir.
Good afternoon. First of all, let me thank Anil and the team for inviting me for this program. And I enjoyed the morning session also. Sorry, in between I could not complete the session there and I could go for an urgent purpose. My name is Dattan, Chandra Dattan, basically a graduate in chemical engineering, and joined ISRO in 1972. I worked almost 44 years there in different centers, which Dr. Narayanan has told in the morning. 2015 I retired from service, and then 2016 onwards I am with the Chief Minister. The 10th year I am continuing as his scientific advisor. That's all.
So in any way, having said this, all the introduction part of it, now let us move on. So our topic today is about, the human-centric design in Industry 5.0, and, balancing automation and empathy part of it. As we all know that, Industry 5.0 is already on, 5.0. And in the morning we were also heard that, okay, whether it is 5.0, whether it is 4.0, whether the transition has been complete. So that also is still not sure about that, but still we are moving ahead with that. Industry 4 in any way, as you all know, yes, definitely, we have been gradually coming down, and then from the bullock cart, and then coming on to the mechanization, and then from the mechanization gone to the computerization, and then again we are now on. So even today, you are seeing a lot of activities being taken place by these, the machinists, or what you can call even the robotics activities are on now. Many places we are hearing about, the kind of surgeries being done, the physiotherapy is being done by these exoskeletons all over. Even 2 days ago, we could see that even in Surat, in India, there is actually some hospitals which are actually carrying out this physiotherapy, where these exoskeleton molds are, just strapped up onto the body, and then trying to see and, trying to reduce the efforts being done by the physiotherapists. So that also is another one. I remember my mother, when she passed, just before she passed away in 1984-85, she was lying down with what you can call stroke. 7 years she was lying down with stroke, and we could see, the physiotherapist coming down, and with such strenuous force, in any way, he was, trying to push the limbs and to make into mobile. But it was not so, but today it is not the case. So now, having said all this, and we are also talking about two physical mode of mobility, and at the same time, the kind of the machinist or the mechanical or the kind of these what you can call the drones. The kind of these exoskeletons and other kinds of activities, robots that are coming into the place, etc., are happening. But whether 5 is being taken to an area where both the machine as well as the man, they should work together. When people are working together each other, then definitely there is always, people can understand the other man's feelings. The people can understand the other person's pain. The people can understand how something has to be done. But what about in case if a robot is going to stand side by side, and if that is going to be there, whether there could be an empathy on the kind of, on the robot, to take care, because it is already programmed. and that program, there is no changes, it is already done for doing certain activity. So how it is going to be. So that is the kind of a talk in any way that we are just trying to see, so whether this is really going to be done or not. So that exactly what we have to see on that. So for this part, definitely, initially, sir, I will just give it to this Rajesh sir, just to take it. Carry on with that, and then we come on.
Thank you, sir. I wanted to talk about one of my jobs, which was at Siemens, a Siemens subsidiary in Silicon Valley called Siemens Pyramid, which used to make massively parallel computers. And the reason I bring this up is because my job as director of marketing was, among other things, to forecast demand. How many units are we going to sell? How many CPUs? Blah, blah, blah. It was a very, very difficult job because you had to make all kinds of assumptions, and obviously the factory depended on my assumptions, right? So I wish, now this is a long time ago, it was about around 93 or something like 1993. At that time, we did all our calculations on Excel or something, right? We used, some data that we had picked up over the years and then tried to forecast. It was a very inaccurate, or I should say incomplete forecast, because frequently we had excess inventory, and or in other times we couldn't supply enough products. So in that context, I want to say what we call predictive AI, otherwise known as AI or ML, machine learning. Okay, that I think is a brilliant invention for manufacturing, because based on various things, based on seasonal demand or based on a variety of other parameters, you're now able to predict much better what the demand is going to be. Therefore, the efficiency with which you can produce has gone up dramatically. So that's a given. Okay, so predictive AI equals efficient operations in manufacturing. The other type of AI is the thing that's got the big buzz these days, generative AI, where it isn't looking at data per se, not numerical data, it's looking at text data, and it can produce lots of interesting text, and I'm sure all of you have played with it. I personally don't like ChatGPT. I find it obnoxious. So I use Grok from Twitter, or I use perplexity.ai, and it produces some really interesting stuff. So how can that help you guys as manufacturing people? Not directly, okay, because for you directly, it's the predictive AI that makes a difference. Generative AI, on the other hand, takes a lot of drudgery out of creating documents. So for example, suppose you need to put together a plan for something or the other, and I'll give you an example. I'm with the IIT Madras Alumni Association in Trivandrum, and I have a task to build a mentoring network. So I gave a detailed prompt to Grok, and lo and behold, it produced a 4-page document on how to create a mentoring plan. Now obviously, as Mr. Balakrishnan and I were saying, the machine lacks empathy. So it's mechanically reproducing stuff that it found somewhere in its vast corpus of data, text data that it has, and it produced something. Obviously, it has to be massaged by a human being. The same thing is true, for example, people have talked to me about how we have a massive judicial backlog in this country, right? There are some huge number of cases. Why can't we have an AI judge? Okay? Sounds like a good idea, but it won't work. You could have an AI judge assistant, but not an AI judge. Like he was saying, there is that empathy, that human factor, you just cannot get rid of it. Anyway, that's a digression. But what I'm coming back to is these two things, the generative AI on documentation and planning and things like that, and predictive AI on your forecasting and manufacturing related activities can be very, very helpful. So this is a very basic, I guess, division of labor using AI. Now, the other part that I'm actually personally excited about is, see, I've been thinking a lot about the Trump tariffs and so on, okay? And to me, as a management professor, see, there are 3 models for success in business, okay? 1, cost leadership. 2, customer intimacy. And 3, innovation. This is it. There are no other strategies. Nobody has ever successfully created a company or made it grow large, except by following one of these three. And if you look at it today, cost leadership, China. Okay? Customer intimacy, maybe America. And innovation, maybe America. My assertion is that India has the potential to be good at all three of these. For example, we, even today, are pretty good at making things at low cost, right? Frugal innovation, for example. And if you look at ISRO, there was some talk about ISRO earlier. ISRO, what it does is it is able to reproduce things that are made elsewhere in the world, high-tech things, at a cost that's 1/10. Okay? Another example may be Aravind Eye Care. I don't know if you're familiar with Aravind Eye Care, which is in Madurai, Tirunelveli, etc. They set out to do eye surgery at 10% of world cost. Do you know what their actual cost is compared to the rest of the world? Any thoughts? Anybody? Their goal was 10% of world cost. You know what they've achieved? Any idea? Rough guess. 8%. Okay. Anybody else? Less than 5? Yeah? 1%. They are able to do cataract surgery at 1% of world cost, and their post-operative trauma, which is a measure of quality, compares to the best in the world. How did they do that? It's a very interesting story. What they did was they made the operation an assembly line. You know, a cataract operation traditionally is a surgeon comes and opens up your eye and, does a variety, takes the old lens out and then puts in a new lens and sews it up. They turned that into 4 different operations. And at each station, workstation, a doctor has 2 beds. Operating on one, that person moves to the next station, and the second person he operates. You follow what I'm saying? Operating on the first, move on to the next, then you operate on the second. And the second person will open up the eye, third person will insert the lens, and the fourth person will sew it up. Absolute efficiency. And that means these doctors are able to do 10 times as much surgery as any regular doctor. You see what I'm saying? Ingenious ways in which India can do manufacturing. That's one. The second is, you go back to historical times, okay? India was a world leader in textiles, for example, small manufacturing, small and medium enterprises, steel. We had the steel, which is called urukku in Malayalam and Tamil. And this was made with, it was high carbon steel, it's nano steel, right? And that went to the Middle East, and they called it Damascene because they thought it came from Damascus, Syria. No, it came from India, right? So we had world leadership in many of these technologies, but we've lost it. But my claim is that, as I mentioned, we can do cost leadership. Secondly, we can also do innovation, okay? We are very good at innovation. We just haven't put the ideas together. Our R&D structure is a little bit messed up, I'd say. The incentive structure is not there. For the faculty, for example, there is very little incentive for research. Let me just finish. Just one more thing. And the customer intimacy, okay? We, at this point, leave it to the West to understand customers. But there are a lot of customers like Indian customers. Where are they? Indian Ocean Rim, okay? The problems people face in Southeast Asia, problems people face in East Africa. By the way, East Africa is going to be the fastest growing population in the world. Their demand is going to go up. And Southeast Asia is already prosperous. So India already knows those people. So we have customer intimacy there as well. So I'll keep quiet now. I have a tendency as a professor to talk. So let me pass it on to Mr. Ajit.
Thank you, sir. So as the topic, because I am just confused in between, people are talking so much about a digital and the world. Industry 5, actually the difference between Industry 5 and Industry 4 is, Industry 4 always talks about automation, new process, new digital technology, everything. But when it is implied, Industry 5 talks about the human face of the human face, whether only automation is sufficient, and if the people's innovations or the creativity, if it is missing, we cannot survive.
So I will also just to start with my experience when we have combined together both this aspect and today's most of the hot topic or the this Trump's main agenda was also this Russian crude. I was practically experiencing, I was heading the Kochi refinery at that point of time where this Ukraine war starts. We usually have a digital things. We have the program where we can completely simulate all the operating parameters using the digital technology in our digital twins. Just for the information, digital twin is almost a digital model of the actual parameters of the unit, how it operates. All these parameters we can stimulate in the digital and where we can combine the value and find out what is the changes we can change in the operating parameters to have the maximum cost optimized product. So that is the principle. So when we have started, this was going in a very good way. Then all of a sudden this issue of crude or this Ukraine war came and government was asked whether he can process Russian crude or not. So we use this technology with the human judgment where we have succeeded. That is why I am telling why this Industry 5 is important. When we analyze the Russian crude, when we want to use it, we found that it is entirely different from the normal. Almost in Kochi refinery, we might have used almost 100 types of crudes from Middle East to Iran to Iraq to US and Nigeria. But these Russian crudes were less used because it has contained lot of chlorides. That is one of the issues in Russian crudes. So when we stimulated, we found that we want to change some of the catalysts in this present system where we have to take a shutdown of 10-15 days and this catalyst is available at a high cost at Germany and we have to get it whether in air freight maybe in 2 days but by ship it may take 1 month time. So with this, what is the value we are going to get and we have to take a difficult decision whether we have to take a shutdown for 10 days and we have to lose that production and whether we have to air freight the catalyst or whether we have to go for by ship. But our values through the digital technology, it is showing we may get this much product, this is the problem. But then there is a offer at that point of time, the Russian crudes we will get at a $10 or $15 less than the market price. So what I'm trying to say, the digital technology we can use and analyze what we are getting the products. We are very clear about what we want to do, whether the catalyst. But now the decision making. There the human experience where it counts, we have to use. And I can proudly say we have calculated all the values, 10 days shutdown, then 30 days of shipping, and we finally decided that we have to go for the catalyst by air freight and bring it, changes, even though we spend 50 crores rupees on that account, in 1 month time we can generate more than that. So what I'm trying to say, there only the Industry 5, the digital technology, where human experience and decision making has to complete together and to play a role. So that is the point what I want to drive upon. Then we will come across some other experience also on the way. Thank you. Over.
So thank you. Actually, I am really confused. A lot of words are there, you know. I don't know. The word sustainability is put everywhere now as a fashion. I don't know how many people have given importance to that. There are great things people talk about sustainable development goals, SDG. Every foreign SDG is talked, but nobody bothers about it. When we are talking about the industries, no, I may be talking something very controversial to what these people are talking, because I have become a generalist now. What for these kind of all industries come? There was a time when all these industries came for meeting the basic needs. Now that stage has gone. All industries are coming up for producing products for luxury increasing. Am I right? Now I say luxury is the enemy of sustainability. How many people agree? So I say luxury is the enemy of sustainability. Unless you are able to compromise on your present level of luxury, you can't do anything with sustainability. Sustainability is the ability to meet the present day demands without sacrificing the stock of natural resources for the future generation. How many people think of that? That is a major thing. Now industry has come for so many things, etc. Basically, now we have to concentrate on only industries which support two things, food and health. That has become. The other thing has reached an ultimatum of luxuries. That's my personal view. Food and health, you can't compromise. These aharam, arogyam, these two things are the most important thing. Let us concentrate on that and come down by, because all these industries need energy. They are in short of energy. And every energy production affects the environment, ecology. Now we are thinking of hydrogen and batteries, and battery, recently there was a study and report how to dispose all these lithium batteries. Going to be a big problem for an environmental issue. Like that, it gets complicated to so many things. Let us have a control over our luxury and so concentrate on the basic needs of food and health. That is about sustainability. I am not going detail because it's a very major subject. People consider sustainability only as a fashion of talking everywhere. They are not implementing anything. Difficult to implement also because it affects the production, it affects the industry, the job avenues, luxury, all these kind of financial position, everything it will affect. Second point is a common term what used everywhere is AI. People don't think of that. What is artificial intelligence? The word itself is wrong. Artificial intelligence means the intelligence created by human being to make the computer work for our needs. That is the definition. Computer does not have any intelligence. It's all manipulated thing by the computer engineers. And if I say computer engineers are the most unethical professionals. They make a password, they make a code and they disappear without telling to even a single person. I have suffered it in my plant. 600 crore plant with fully automation, I did it. For making the total automation, the L&T has deputed a young, smart software engineer and he did it for 6 months. He got a better job, he escaped to Bombay. Over. Nobody knows what he has done it. Very unfortunately, I didn't put another engineer to follow him and understand. Even if I put it there, he will not do it. A big flight, from New York, my children are in US, every year I go. From New York, when I want to come to Dubai, via Dubai to see, the flight, could not take off because there was a bug in the software. The whole night the flight was grounded. People told the particular engineer has to fly and come. What a system! Because he only knows the code. That is his trump card. Unethical. Why I told about the artificial intelligence is, there is some fundamentals. We human beings are a special creatures who are the only people who has got intelligence. Why Creator has given intelligence to us? Because first they have given sensing organs for all animals. But in giving sensing organs to us, he was a bit confused. He has not given the full capacity. Our sensing organs have limited range and capacity. Many animals are having higher capacity for seeing and hearing. Do you agree? Even smelling. That is why police people use sniffer dogs, for many things which a human cannot do. So that sensing organs are much sharper than ours. So we understood also, human has understood our sensing organs are comparatively less smart than other animal things, etc. How we could understand it? Creator has given a special dose of intelligence. That intelligence play all these things for understanding our limitations of the sensing organs. So what we did? We started with the intelligence, we started developing sensors. Even this box, what you are wearing, hearing aid, what you are putting, are all sensors. Enhancement, augmentation of our sensing organ. And also we could understand our brain with all this master control of storing, we have got limitations. It has got limitations in 3 aspects. Storage capacity is poor. When information is flooding like anything, etc., we are not able to store. So a lack of storage capacity is one thing. Second thing is, when so many things are there, we are unable to retrieve fast. Many times it takes time. We want to recollect something and then, oh, I'm not able to recollect, we will know on the things. So the retrieval was slow. Third thing is, because there is a bundle of information which has been put in the whole neurons there, etc., stocking, classifying and putting into the rack, it doesn't do properly. That is the reason and we are unable to retrieve it. These 3 aspects, understanding that it is our limitations of our brain intelligence system, we made computers. Computers are made for overcoming our limitations in many aspects, and we made a computer to work. All these factors. Other than that, computer does not have any intelligence. Actually, the artificial intelligence is not correct. It is augmented intelligence of human being. Everything is controlled by human being. And the data bank. Now the thing is, computer, even if we are not giving a data, we have made arrangements for computer to automatically go to all servers everywhere there and search and catch things. Again, it is data. In that data storage, appropriate time, the computer retrieve and process it and make decisions. It depends upon what kind of algorithm we give. And if you are not giving the proper algorithm, there will be miserable failures. The major 2 failures of our rockets, Ayapadasan Pillai will be knowing it correctly, the SLV-3 as well as the PSLV. PSLV, there is a control system. Control system rockets, we are given certain range, up to plus, minus. If it by hand goes, it will not work. So, plus and minus, we have given certain range. I mean, the trajectory it goes, for this kind of movements, for corrective actions, control rockets are used with some plus minus. That plus minus is given because beyond that there will be a limit. You cannot keep it open. You should give the range from what to what, plus side to minus side. So because we have got stock of propellant is limited, we have to control with the proper care, we should use it. With that availability of system, etc., with a plus range. When the deviation has gone slightly more than that, etc., system failed. So we could not recover. Like this, there are n number of cases in the computer. There is the automation. When we talk about the human element, it comes without human element. A computer without interference and proper monitoring and appropriate corrective actions, a computer cannot, it doesn't have a thought process. That is the major thing. I think people don't understand it. Why morphing some pictures and putting, etc., plenty of things, comes in the WhatsApp, etc., people feel that is the intelligence. That's not intelligence. So let us be very careful about the artificial intelligence when we are putting to the industry on 3 aspects. One is social aspect, ethical aspect, and environmental things. That environmental things, etc., we are not properly fed it. And when you are keep feeding it to also, we give with the data source. And emotional part of it, that is the main issue. Emotional part, by giving data, to what amount of data we can make and compensate on the emotional part. Please think of it. As a human being, if they want to simulate my emotions, maybe my behavior styles about 6 months or 1 year's data you give to computer. 10 times if I put bloody shit means it will only record that. And whatever terms I make use, frequently will be stored in the computer, and appropriate time it will make it use without any emotions. This is a very, very dangerous thing. And ethical thing, when you are talking also, this AI is going to be very, very dangerous in the near future if it is handled by a set of people who does not have any social thinking. This is the major issues with the artificial intelligence. I only touched, there are a lot of things touched, only 2 words, the sustainability. Sustainability, please give importance for it. Otherwise, with this kind of changes, what happens in the atmosphere, in the global warming, and mishaps happened, etc., the sustainability is something we should be very careful, and sustainable development goals, SDG 17 numbers, in all manufacturing industries to be taken care by converting to recycling, reusing, repair and use, and reducing the waste, and optimization of the raw materials, and reduction of the waste and processing of the waste, all these things to be done very carefully. And artificial intelligence, just to be very careful, it should be going to the wrong hand. That is the end of it. Okay, thank you.
Yeah, it's a good one. So actually we support on that one, because definitely, if the whatever the input that we are giving, so definitely you can only get the output in that manner. No doubt about that. However, there is one single thing. I'll just come to you, sir. There is one single thing, just wanted to know about that. Because the data, whatever we are giving, and as you said about even the sustainability of the planet, everything we have to see. Yes, sustainability need to be given, but why not we have some proper rules and regulations to be followed? Are we having on that? So that is one important thing that, just wanted to check on that. Because there are drones, out of my, again, coming back to the, the industry side of it. Yes, I have heard that, recently in BPCL, and of course, it used to happen in the Middle Eastern countries, but recently in BPCL, drones were used to check about, the ground conditions of the pipelines and other kinds of activities. And the people do not have to go to that area because, at least, they are saving the life of the people to go around, because there may be so many hazardous materials, sour gases, etc. could be there. And in that area, these kinds of, the drones and other mechanization activities could be there, and that could be done. Shutdown time could be reduced on that one. In Saudi Arabia and all, these drones were being sent into the flare stack, even when the plant was running. And so that, they could see and take photographs of that, and before the shutdown is already planned and announced, they could get the picture where the corrosion takes place, and accordingly the corrosion could have been corrected, and when the plant is already around with that one. So there it was also the correct part, it was done. So it all could save the lives of the people, definitely no doubt on that one. So it all could save the lives of the people, but at the same time, so we must also be under the ambit of these particular rules and regulations. Like drones, I have heard, and also even the laser beams, whatever we are talking, even the drones and all. Even I have heard that in the area of Texas and other, in US, the people were, flying the drones, what you can call violating the norms and regulations around that airport. And so they had to shift it, and they became more strict across. Even recently, even here also, in Chennai, they could hear that the drones were being flown by somebody, and, they were having some kind of, issues and so. So, but why we cannot, get onto a proper inspection of these kinds of, the regulations, whether how they are violating or not? Why it cannot be done? Mechanization takes place, human activities are required, but at the same time, these are also part of the requirements to be followed. But does it not think that, okay, this is a part of the responsibility of even giving a good policy as well? That's what one of my questions in any way to you.
Let me see if I can respond to that with a couple of examples. You talked about saving human lives and reducing the risk to humans. 2 examples. One is a company called Gen Robotics, which is a Trivandrum company. So they have built a robot that will go out and inspect drains. So instead of manual scavenging, this machine will go there and do it for you. So you've all heard of people dying in the drains because were exposed to carbon monoxide or something like that. So this literally could save lives. Plus, the life of a manual scavenger is pretty bad. So Gen Robotics is an example of something where this kind of artificial intelligence is built into a device. The other is something called ISRO. This is a company that was incubated at Maker Village that I mentioned to you earlier, and Dr. Rajshree is aware of that as well. It's an underwater drone. Again, what it does is it can save lives, because otherwise, if you didn't have this drone, you might need to send a human diver down into the depths to look at, for example, undersides of ships, right? Ships get barnacles and so on, and they need to be inspected periodically. It's a little dangerous. Whereas this ISRO, which is a tethered drone, can do that. Plus, it can go look at the basement structures or the foundations of bridges and things like that in murky water. These are things that would potentially put a human life at risk. So here, right here, these are both from Kerala. ISRO is in Cochin, and we have Gen Robotics, which was incubated in Trivandrum, but now I think it's in Bangalore. So there are many ways in which machines could actually improve our lives and reduce the risk to life. Now let me just switch for a moment and move to something else about empathy, which Mr. Balakrishnan Nair had mentioned before. There's a book by, and I don't remember the name, by Kazuo Ishiguro. You may have heard the name because he won a Nobel Prize in Literature some years ago. So he talks about a future in which people have personal robots, okay, that are their companions. So for example, you have an elderly person who doesn't have much human interaction. The children are not there, you know, their spouse is dead, things like that. So you have a robot that has been infused with a personality which is related to, you know, this person's own personality, and that becomes something that improves their life dramatically. Another example is where in the early days of AI, in the 1960s, there was a program called ELIZA. It was a pretty primitive program, but it was found that people who used it became hooked onto it. That is to say, ELIZA would ask you questions that are simply based on what you said. So you say to ELIZA, you know, I have a headache. So ELIZA would come back as a sort of psychotherapist and say, oh, you have a headache, tell me more about it, right? That level of primitive behavior itself was good enough to improve the lives of the people who were talking to it. So there are many ways in which artificial intelligence could be helpful, not necessarily industrial ways alone, but there are problems also with generative AI. You know that it hallucinates. It can just lie to you, okay, because it, for example, it may take data from dubious sources. Today, generative AI looks at things like Wikipedia, and most of us know that Wikipedia is a somewhat biased source. And similarly, you have the contents of Google's archives or Meta's archives or whatever, and these are not necessarily true. Okay, so one of the things that we need to do is to be pretty careful about verifying what generative AI tells you. Do not take that at face value. But with that caveat, there are a number of things that generative AI can do for you. But as I was mentioning earlier, for, I think, industry, it's the predictive AI that actually is helpful. And contrary to what Mr. Dattan was saying, I do believe there is, if not intelligence, there is computing capacity there. Okay, and if you give a lot of data to a problem, if you throw a lot of data at a problem, you can usually find patterns which are not visible. So for example, today, if you use predictive AI, you have machines that can read an X-ray better than the best human radiologist, simply because it has more data, because a human being's ability to collect data is obviously limited by bandwidth and so on. Okay, this has infinite capacity, and it literally is better than any human being. Similarly, there are other examples where when you're using predictive AI, you can, you can observe patterns. Example, they found out that in big grocery stores in the US, there was a very strange phenomenon where on Friday nights, they sold a lot of baby food, and also they sold beer. And people were like, what's going on? And what was eventually figured out was that young mothers were sending their husbands, to the grocery store to buy baby food. And the guys also bought beer, right? So this kind of correlation is not obvious to us, okay? But when you have lots of data to crunch, you find various patterns. And that's something that AI is pretty good at. So with that, I'll pass it on to you.
Since so many discussions whether this technology and whether it really helps, I'll tell you my life example. When we joined in BPCL Kochi refinery, we have a system called the flyer system, 150 meters height. When we want to do an inspection during a shutdown, we have to climb monkey ladders of 100 to 1,000 steps over to make that inspection. When I have gone to, I said, Middle East, they said, you have to make the inspection. Then I have seen that they put you on a crane onto the top on 150 meter with so easiness. Now, as Balasan Nair has rightly said, now we have drones where we have to make the inspection at the ground level. So whether it really helps your job, surely. As another interesting aspect I can say, we have a single buoy mooring system at 26 kilometers away from the Cochin seashore. So we have underground pipelines passing from the mooring system to our refinery, and even through the cities of Ernakulam, it is passing and coming to our Kochi refinery. How to make inspections of this pipeline. Earlier we have a different system where he had to do the, but now we have an intelligent pigging where we can throw these pigs with ultrasonic instruments where it will give the complete picture of the lines where the corrosion occurs, everything where we have to. So, how to use your technology to the human values and where you have to use your judgment is your smartness. So, what I am trying to say, always anything when you proceed with the technology, there will be ups and downs and people will be there to use it rightly or not. So, that judgment, there only this Industry 5 when we say how to use it cleverly and how to use. Similarly, I can say when it has come to a predictive maintenance, we have so many turbine systems where usually we have monitoring with the vibration sensors or temperature sensors, it can work. But now the technology has gone into such a level, it is only monitoring. We can predict with the same conditions whether how much time this can run without failure. And we have gone further steps. If we want to run more time, what are the arrangements? We can stimulate the conditions so that this will not fail for a long time. So what I'm trying to say that this artificial intelligence or the technology which will give data, and this data to be used in what way is the human intervention, where experience and innovation counts. Similarly, I can tell you when we have some foundries, etc., old times, people are carrying hot material and bringing it to the forging shop. Now, there we have seen that that is the toughest job where we have to handle manually, where we can use a robot, or as it has already said about cleaning inside a real space where difficulties are there, where we have to use the. It is not that for all the jobs you have to use the robot. So that type of intelligent decision, if we can take in a company or in the industry, this will be very beneficial. That is why I said from Industry 4 to Industry 5, the human judgment is always a big aspect. I rightly point out because Datan Saab has specified you have to control the, because I have a discussion earlier also on a climate change, where the climate change people have said there is no solution because always the use, but we have to restrict the use. That is a point I really appreciate. When why we want to have a 8-bedroom house or a 2-bedroom house or a big houses, where there the government has to make a control for a human being. This is the maximum required. If why we people require
40 cars, even though he is having money, but that uses energy. So that is where, rather than the intelligence, the people have to see what is the real requirement. If a fellow Ambani is using 50 cars, whether it will affect your environment. 100% it will affect our environment, where we are producing more and not using, where government can bring controls, that will make a difference. Not on the intelligence, it may always support the system. That is my point.
I just, other than what these two, sustainability and artificial intelligence I talked to, I wanted to tell one more point as a role of industrial engineers. Yesterday we had a full session in Hotel Hyatt, with the Science and Technology R&D Summit. Actually in our country, what an amount of research is going on in colleges and various institutions. Even 5% of those things are not coming to the practical things, to convertible to the human being and to the society. And it is in our country, it is very poor. There is a problem of translation. Actually, Anil has started MTech in Translation Engineering in Barton Hill School. I have interacted with the students many times. They are doing excellently well. Whatever, again the scientific inventions, scientists doing and engineers doing is totally different. Scientists, when they do a kind of new ideas and come out with an R&D product, they never bother about converting to the practical system. How engineering and industry is needed, etc., they don't. But engineers, when they make a system, etc., it is more relevantly they do it. But in spite of all these things, these research outputs, when we wanted to convert or translate to a commercial, useful product or systems or a device, there is a hitch. Many times on the way there are problems. This can be addressed only by an industrial engineer. In ISRO, we have had a technology transfer group. I used to monitor their activities, select very smart people to interact between the R&D person and the production people. Their role is very, very critical. And then only more and more R&D system will be converted to the commercial production process, which will be available in the market. When it is available in the market, it should make reasonable profit also. That is the problem. Many times these R&D things which does not sustain. As he has told, a very beautiful system. That day, yesterday there was an excellent presentation by Gen Robotics. They are about the systems what they make use for bedridden patients for lifting, converting and moving, giving exercise and all other things. Excellent system. And especially that robotic systems which used for drainage cleaning and scavenger work, etc., is excellently well. Only thing is, in our country, where the manpower, surplus manpower is sufficiently high, we should not go for, serving food to the table, automatic, robotic. If you put it in the hotel, for serving food, etc., how many boys and girls will become jobless? And if you started robotic for driving our car, lakhs and lakhs of privates will become jobless, etc. We can't think, let us don't think of that. We are not attained that state. We should use only for making use of difficult, complicated earth movement, digging up the things and doing things in the remote way, etc. We should give more concentration and such things should be brought out very clearly. Over. Thank you.
Now I think in any way now I will leave it to the the floor to talk, interact with them.
Thank you so much to the esteemed panelists for such an informative and thought-provoking session. Now the session is open for question and answer session.
Sir, I have a question.
Yeah.
Sir, all the four of you are subject matter expert, but all the four of you are going north, east, west, south. Each one not connecting each other, but we got a lot of information. But however, here the topic was human-centric design in industry. Whether it is industry 1.0, 2.30, what is 4.0, technology keeps on changing, point number one. Next is, jobs are always available in plenty, but skills are empty. So each one has to upgrade his skill, that is two. Industry change over to automation. The same, if you divide the economy into industry, service and business, in industry to automation, In the banking industry into computer, in the case of business industry into e-commerce. Losing job every 4 years, like every 4 years, that is common. So what is sustainability is like MRS management, like Mrs. Management, maintain, retain, sustain. That's all. So how we have to gear up to the next industry level are those things that has to be brought into the knowledge of all the youngsters also. One of the best tagline for Tata is, it is a 120-year-old industry in India. They always say, even today, for visibility and publicity, we also manufacture steel, etc. So let us stick to that sustainability, because technology keeps changing, but the technology is driven by technical people, all those who are present here only. So what is required for that one? Enlighten the youngsters, sir. That's all.
Good afternoon. Myself, Dr. Ajit Kumar. I was working with DRDO. Now I am a retired person. Very interesting, actually, 4 different facets of this AI-driven industrial engineering, human-centric, has been brought out. I will touch upon 2 points which have a little bit of experience, actually. The first one, quite recently we find a lot of academic courses on design thinking and application of AI for design thinking. That I'm not sure. This, I think, is the human-centric part of it. In design thinking, we all talk about empathy first. Empathy here means not support part. Empathy means to stand in the shoes of the user, actually, understand the problem and then doing business, actually. So unless earlier we all used to know that actually if you have a good idea, if you've got good technology, business will thrive. But gone are those days, actually. You should have a problem in the society, you should understand it properly, and that should be the starting point of any business. So that is first, as I understand, the human-centric part of AI. The second part of it, yes, AI, as rightly said, Nitin sir also was mentioning that cannot go beyond the human thing. Yes, we create all these things. We can consider is part of supporting us. Towards that, we heard about the digital twin technology, what is being used by the industry. In fact, we also did, in DRDO also we did. For system of systems, we apply this digital twin technologies to have a digital version of the complete system available with us. On and off, we try out any disruptions that can happen, and we do that, actually. So I think these 2 things, these 2 points are very valid, which has been discussed over here, and probably some more discussion can happen in this regard. Thank you.
Yeah, I've been teaching a workshop on design thinking for 14 years at IIM Bangalore. And what we do there is to ask questions of your potential customers in a very naive manner. You don't go in there with any assumptions. In fact, that's what designers do, right? A designer can design a microwave oven today, a computer mouse tomorrow. They're domain experts. But they're good at understanding what the real problems are that people have and then try to respond to them. And I'll give you an example of how what we think are the problems may not actually be the problems. You've all seen photographs of women carrying big pots of water in Rajasthan, for example, right? They have to walk for miles and miles to bring water. So somebody, I think a local collector had a very empathetic idea, and that's what he thought. He said, let me not make these women walk for miles. Let me create a water tank which will be supplied by tankers, right? So he put it up, and there was a water tank made available to the villagers. None of the women came. None of them came to it. Why? Because unbeknownst to him, the 3-mile walk or whatever they did was their personal time with their friends. If you're at home, you're looking after your husband and your children and whatnot, right? This was their me time. They discussed, they gossiped, they discussed who was going to get married to whoever, etc. So they did not want to lose it. So that's an example of how we as outside observers, if you do not really understand what the person's problem is, you solve for the wrong problem. So we make people go and treat the customers as sort of anthropological objects, in the sense that suppose you're a person who comes upon a brand new tribe that has never seen, that's living in some remote forest or something, how do you approach them? So design thinking, I agree with you. Now, although design thinking has almost nothing to do with AI, literally nothing, okay? It's more of a human-centric approach. And I think that has to be, I talked about customer intimacy earlier. On average, I would say Indians have not been very good at customer centricity over the last few years or few decades. But this is something we should be working on so that we can be better at selling things to the right customers.
Sir, during the discussion, you mentioned about 3 points. That is cost leadership, customer intimacy, and innovation. See, my question is, how one can pursue innovation without compromising the cost? For example, you mentioned the example of Gen Robotics. Why that system is not widely popular or implemented here? For example, a robot to clean the manhole. Why authorities are not implementing it? I think because of the cost factor. So how can an organization or a municipality or a corporation pursue innovation without compromising the cost? Can you delve upon this, sir?
Well, he was mentioning that there is both cost and regulatory issues, and safety issues and so on. But in general, let me respond to you by saying, often when you innovate something, it is going to be expensive. Okay? It's only when that innovation filters down and becomes broadly acceptable that the costs come down. Scaling. You're industrial engineers, right? If you have economies of scale, economies of scope, right? When the numbers increase, the costs come down. So as a simple example, when the first newspapers were introduced into Kerala, only a few % of the people could afford it, right? But over time, everybody can afford it. Same thing with bicycles, TVs, cell phones, right? Today, even lower level people can afford it. So what I'm trying to say is that it's difficult for an innovation when it first comes out to be very cost effective or cost sensitive. But it's because of percolation and acceptance that the cost can come down. I hope that answers your question.
Sir, good afternoon, sir. Actually, the topic which you had said is about human-centric and stated as human-centric design in industry. Now, once when you're saying human-centric, now isn't the word AI being too much excessively used? Does it go with it? It does not. When you're putting a human-centric mode, and AI is something that is automatically done even from the years and the years in a past also. So what excess an AI does to it? It doesn't. So then when we talk about empathy, you talked about generic AI as well as for predictive AI. Now when it comes to generic AI, being while doing the classes and all those things, the point is now the students will be more getting into the generic AI. Now their creativity gets lost. That means the coming generation will lose its creativity altogether. So now coming to the design portion, that also will get affected, right? So now having an AI driven in a larger scale, is it required or not?
Yeah. That's a very, very valid, intelligent question comparing to the earlier thing, etc. Why certain things, very useful invention, Gen Robotics, like that things, why people are not practicing it? Let us first of all understand, we are a country with surplus manpower. Like 2 things I told, serving the food or Swiggy giving the food to the houses, if started giving drone for supplying the food to the doorstep, is it possible in our country to implement it? No. Maybe after 50 years, 100 years, it may come. Now, it is a livelihood of about 1 lakh, 2 lakh, 3 lakhs, boys and girls with a mobile and bike alone, they are able to serve the food from all hotels to the doorsteps. If drone you put it, it will not become practical certain times. Similar way, the driver, driverless car, if you put it here, etc., it will not run it. It will take time. Many automation, even for, in common now mopping the room and etc. There is a very cute machine is available. You program it and run it every room it goes and mop etc. You pay about 400 rupees, somebody will come and do the mopping. There are people queue coming, etc. We won't do it. It is our country's present situation that we should understand about it. Maybe after some time we will put it. But the mobile phone is a beautiful invention. I mean, even the lowest category of people, use the mobile phone for sharing so many things. So there are certain innovations which has become very, very common because of its things. There are certain things which will not become so common. To his question, one thing, actually in academic places when PhD theses and research activities are being done, the guides who only bother about the number of PhDs, they never bother about what kind of subject is given to the candidate. Very unfortunate. They will be only considered within 3 years or 4 years how fast this can be completed and it can be awarded to a candidate. Human-centric problems in the society in different fields, there is no forum for having a formal discussion and understand in particular field of engineering or a science, etc. What are your problems? In which problem, if I make a R&D studies and come out with a thesis, how it will be useful to society. That interaction is not here even now. Yesterday also I was telling to the R&D summit also the same thing. And that summit was made for scientists who do the R&D work and the industrial people, all these come, etc. And one more point I emphasize, the industrial engineers is the link between these two guys who can convert things. And the scientists also should, our startup mission CEO was there, Anup was there. Anup has told very clearly, every scientist when you are making a system development, when you come, etc., you should keep it in mind that this is to be translated to a device or an instrument or an equipment or a system which can be produced in bulk and can be marketed with a competitive price. Then only it will sustain.
Anyway, thank you very much.
I'll just take 1 minute, okay, because we're running out of time. See, your question was about what will happen if generative AI, it's generative, not generic, takes off. We're going to lose those facilities, okay? With calculators, nobody can do arithmetic in their heads. With Google Maps, okay, nobody can navigate themselves. So if you depend too much, and there are studies that show that if you use generative AI a lot, your cognitive skills decline.
Anyway, thank you very much. And now I just want to conclude everything. And just in the conclusion, I would like to say that, that artificial intelligence is the word that is going to stay long. Yes, but, it should be understood carefully and it should be utilized carefully. So that is the first part of it. Number two is about, human involvement has to be there, because definitely it is not that, okay, human can be eliminated and then, artificial intelligence can do everything. So how we are interacting with the machine, that need to be taken very carefully. Number three, yes, there are sites and there are technologies where, we cannot enter into. Like, industry-wise, as Ajit Kumar sir has said about that. Yes, there, wherever it is not possible for the humans to go around, yes, let the artificial intelligence and the machine, let it go. It is not that, okay, you can avoid and everything. So that is another part. And then, use only when, it is very difficult. And sustainability, as Datan sir very clearly said, sustainability also need to be in place when we are considering all these kinds of, designs and other kinds of innovations in technology. No doubt about that one. And finally, we should understand, about the apprehensions of the human beings. We should also realize that, the humans are, inevitable on this world, so we cannot avoid that. And then finally, utilize that particular, the technology developments in the most useful manner. And thank you very much, for listening patiently for these 1.5 hours. Nearly. Thank you very much. And thank you very much to the III for giving us an opportunity to be on the panelists across over here. I thank, Datan sir. I thank, Rajiv, as well as I thank, even Ajit Kumar sir for this wonderful discussion. Thank you.
Thank you so much, sir. Now I invite Dr. Suresh Subramaniam, Director, CT School of Management, to kindly present the token of gratitude to our esteemed panelists. Starting off with the moderator. Thank you. Thank you so much, sir. Now we will be moving on to the next technical session. Now we will be moving on to the next technical session. This session will be led by Engineer G11, CEO K-Space, former Deputy Director of VSSC. Sir, please.
Okay. So, good evening. Thank you for this opportunity by IEEE. Next 10-15 minutes, I'll just dwell on the Kerala Space Park initiative by Government of Kerala. We are crossing just 2 years in existence. We are an institution under Government of Kerala, under the Electronics and IT Department. We want to make Kerala as a aerospace industries, products and services hub. So that is the ultimate objective. We'll have 3 verticals there. The space segment, which is my parent sector, the connected aviation and the defense. Coming to the space sector, If you see the pie diagram on the right side, there are 4 major verticals. The rocket, what you see, the satellite which we carry to the orbit, the ground segment covering the ground stations, computer network, etc. And fourth and vital is regarding the application segment. That is the major chunk. The civilian and military applications, it is very much intensive in India compared to the application development for the common service sector. If you see the economy, today morning we heard about what ISRO has achieved on the technology front so far and what we are aiming for. Today we are talking about the economics part. The space economy is supposed to grow from $640 billion to around $1 trillion by 2040. That is the type of the minimum forecast what is available. To achieve that, we have different segments which has to grow and capture this business opportunity. So the details are listed there. Next one. I think we all have to worship this fellow, Elon Musk. What he brought in to the space segment, it is something amazing and something which cannot be imagined a few years back. We know the influence what he has brought in to the business side of space technology, and with the repeated reuse of systems, he has brought down the launch cost phenomenally. From $10,000 per kg is currently operating at $1,500 per kg and is going to target $200 per kg with the operational phase of Starship. So that is the type of influence is brought in, and we all have lot many lessons to be learned from him. India, we came up with the National Space Policy 2022 to capture this type of business opportunity and avoid being left behind. We have in place the Indian National Space Promotion and Authorization Center in space, promoting and regulating the space activities here. So there are multiple verticals. The space sector getting opened up for the private entrepreneurship. The captive high value infra, whatever created by ISRO being offered for the services of the space sector, and the knowledge sharing and mentoring for the young entrepreneurs. And the commercial arm, NSIL, the New Space India Limited, is part of the new ecosystem. And as of now, there are 250 plus startup companies operating here in India, and several names are well known to all of you. Next. This is what we want to be. We are hardly $8.4 billion worth Indian space economy, serving roughly around 1.8% of the world economy. We want to be a $24 billion space economy by 2033, and by 2040 we target for $100 billion. Next. The next vertical what K-Space is targeting is the aviation sector. I think this story is well known for all of us. We are the fastest growing aviation sector in the world. Third largest domestic market in the world. And the type of investment happening, what do you read? The private sector is ordering bulk numbers of aircrafts, both from Airbus and Boeing. These are very satisfying for every Indian. What we lacked is an initiative to promote the industries connected to the aviation. That is where we are lacking, and we are yet to. It is really a shame for all of us not having our own civilian aircraft yet. Yes? The third segment is regarding the defense sector. Again, we are the fourth largest defense budget, fourth largest military in the world. We have tremendous investments happening. It is an ocean of opportunity with the Make in India initiative, what is offering. And if I am not mistaken, 23-24, the defense export was around 30,000 crore. It is a great opportunity, and we all should see how far we can grow, capture the opportunities, and develop indigenous capabilities and enhance our production. Yes. Now, the question regarding the Kerala. Why we have to be in Kerala? For this space, definitely the ISRO community is here. It is this place where we started the whole journey. And we have the BrahMos Aerospace, which is sitting here in Trivandrum. We have the cluster of aerospace industries. I am now connected with 62 aerospace companies, small and big, in Kerala. And I am aware the number of institutions operating in Kerala is over 180. And this ecosystem is tremendous, and they have been mostly serving the ISRO community so far. And let us explore how far they can grow and develop business beyond the ISRO campuses. I think ISRO has given the experts for our community. We have great experts in different disciplines living within us in Kerala. And the skilled manpower, definitely we all appreciate. And the R&D institutions beyond ISRO itself, we have several of them situated here in Kerala and Trivandrum. And the education system, the health care and logistics, with the latest addition of Vizhinjam Port, I think we should all be very happy that such a wonderful ecosystem or logistic support is available within India. Okay, the God's own country is next. We have to say that who are all going to move this initiative? So far, we have been thinking that there are ISRO centers and a few thousand people are working inside and they are having a very wonderful life. That was the attitude from the government. We never understood that it is an opportunity to develop business around this institution with the support or indirect support of institutions itself. I think we have to rewrite this story, and we have to take advantage of proximity to the ISRO institutions, including IIST. And the institution, BrahMos, they are a leading institution in the defense sector. Why we can't integrate the space and defense and capture the opportunities? And we have the NBOL, we have the Cochin shipyard, having the greatest honor of having the first and only indigenous aircraft carrier. And we have the logistics. I think there may not be any other geography in entire globe with the 4 international airports within this 500 kilometers across Kerala. I think the 5th one also is coming. And the national highway is connecting Kerala from the north to the south. And the width, maximum width is 70 kilometers, or hardly the average width of the state is less than 30 kilometers. I think these are all certain advantages we all have to appreciate and take advantage. Vizhinjam Port is going to be a game changer. We have understood that before commissioning, it has gone to a success story, and provided we create the infra around the port, it is going to create wealth for the state, wealth for the community here. The Kochi-Bangalore Industrial Corridor and the city outer ring road, which is going to come up shortly, connecting the Vizhinjam Port to the National Highway, that is going to be an industrial growth corridor. For the industry development, there are several institutions. The Kerala State Industrial Development Corporation, or KSIDC, is taking the lead. We have the KINFRA, the CIDCO, and the new entrant is K-Space. Next. We have already initiated several projects. Those are under different stages. We have the first project coming up at Pallipuram next to the Digital University. We are starting the construction of a common facility center and R&D center around 2 lakh square feet, which will house the common facilities as well as the incubation and R&D facilities to support the startup ecosystem. Adjacent to our campus, the MSME is putting up the Advanced Manufacturing Technology Center, which will extend the proto-manufacturing support for the local industries and R&D institutions, provide the skill-up training for the students from ITI to engineering graduates, and the entrepreneurship consultancy support to the new entrepreneurs. We are developing around 15 acres there for leasing to the universities. Out of 15 acres, already 8.5 acres are already booked. And next one. This ecosystem, what you see in this campus, is going to be a unique ecosystem. It is developing as a Kerala Research Park. We already have the Digital University and Digital Science Park in the same campus. The Kerala Defence Innovation Zone, it is coming up in the new Emerging Technology Center being put up by Startup Mission and the Technopark working on the software development. So this is going to be a very unique ecosystem available in Kerala or in Trivandrum. Next one. We are in the last phase of acquiring around 13.5 acres close to the IST and LPSC at Valiamala. We'll have 3 major projects coming up there. One connected with the liquid propulsion systems. Next one, the R&D to product development center, and third one, the drone research and testing center. This is going to be a very unique ecosystem to support the evolving drone technologies. Next. We are in the final phase of acquiring 60 acres close to VSSC, very just across the Aklam Lake, where we are going to put up a facility for the aerospace control systems, aerospace inertial navigation and control systems, avionics facilities, and precision and microfabrication facilities. We are also getting support of around 100 crore from InSpice to put up the common facilities at this center. We are shortly getting around 25 acres in Kochi to put up a aerospace industry complex. Next. I told about the BrahMos Aerospace. They are on the expansion mode. They have already requested for 200 acres from Government of Kerala to put up their second unit in Trivandrum. That decision is awaited very shortly. We want to develop an integrated defense innovation park or industrial park adjacent to these 200 acres, where we'll handle the metallic and non-metallic systems as well as the explosives manufacturing and testing. This is going to be a unique ecosystem in combination with the BrahMos second unit. Next. I think the importance of composites in the modern era, we all know. The entire composite systems for the space we are manufacturing in our Vikram Sarabhai Space Center, the composites entity. We have a great many experts available. The entire technology is sitting with us. We are in the process of putting up a composites center at Thonakel, around 30 acres we are going to acquire and put up the facilities for the modern composites systems required for space, aviation and defense. Next. We integrate the whole process through our website, and we are, next one. We are having several connections created, functionalities created to support the business, including the market research data, the job seekers registry, the resource persons pool, and we have the space advisors pool, etc. Next. I think this is one wonderful thing happened in the last 2 years. As on today, as I told, we are connected to 62 aerospace companies, and mostly they are in Trivandrum. All these institutions were mostly pre-existing here. My job was only to network them and bring to the ecosystem so that we can utilize their collective synergy for the further advancements. Next. We are also creating partnership and MOUs. We have already done the MOUs with ISRO centers of VSSC, LPSC, IASU, the IAST, Digital University of Kerala, the Kerala University, the STPI, etc. And the further MOUs are in progress with SEDAC, KTU, the InSpace, and IIT Pravartak. And several more, 3 more drafts are ready. One is with Murthy sir, and the madam's draft also is ready, Trust Park. And SFO Technologies, we are finalizing. So that's why the integration is happening. We are together. I'm also happy that we have created the networking to make room for people to collaborate. We have created 2 consortiums already. The first one between Aero Precision, Winwish, and ATL, Adams Technologies. And second with Techlog, then Okabasu, and Airlay. The third one also is in the making. It has so happened just now back. Another 2 companies, the Mr. Evo and Mr. Evo and the other fellow. Okay, I think we are doing that agreement tomorrow at Starbucks Lulu Mall. I think people are coming forward with ideas to create collaboration and work together. Okay, I think no damage done. So you are targeting Murthy sir. Okay. I think we are also creating the network across India. We are founder members of the SIA, Satcom Industries Association, the Indian Space Association, ISPA, then CRT and Inaugural, and CAE. The interesting development is the networking of academic institutions and enabling the collaboration and linkage between the academic community with the R&D and the industry. I think this is something which was lacking so far, and we are enabling that. And this is going to be creating a strong bondage in providing the opportunity for internship and project work with the industry directly. I think we are ready for the announcement. By coming month, we will be going forward with the formal inauguration of this program. I think the last statistics, okay, the 62 companies put together, it is creating the number of employees, around 5,000 people are being employed by these institutions with whom I am now connected. Around 1,000 300 crore has been invested, and 800 crore is the turnover of the companies as they reported. I think this is a journey which has been just initiated, and probably we can target for a greater future. Thank you all.
Thank you so much, sir. Now the session is open for question and answers.
Yeah, the third consortium, Arxen and MSTU, I think that is going to happen tomorrow morning.
So very good afternoon, sir.
Hi.
So a small question.
No,
I think it is the third largest in the aviation sector. But however, we don't make a single engine. The only engine which we have got is a Kaveri. Other than that, none of the aviation sector will fly without an engine. So with this present status quo and all those things, how do you think that when we are always on to the avionics part, nobody is putting on the engine part, when we are doing all the propulsion systems and everything, why the industry is not looking towards it?
I think you are from defense, from your uniform.
Otherwise also in the same, so look at it, the same thing.
Okay, I think let me tell you, I think I visited the GTRE testing center where our Kaveri engine was being tested because they called for some sort of a consultancy with me and my team. I think the answers are already available to you, right? I think when we started the space mission, I think Narayan, our chairman, told, say we started with a Nick Apake sounding rocket given by US. Okay. Above we put a payload donated by France. And I think we are not having that computing facility. I think computer was donated by Russia. So these three people almost donated every possible thing. We started off from there, right? We had a mission to develop something. When Kalam sir started the launch vehicle program, we have only seen some photos or some documents, not detailed, only pictures, right? From that, we put a national mission to develop something. That is the result. Okay? I think the aero engine can be a national mission, and we can do it. We have the potential to do it. So what is lacking, you can understand. I am available here.
Thank you so much, sir, for an informative session. I invite Dr. B. Anil to kindly present the token of gratitude to our esteemed guest, G. Levin, sir. Thank you. Thank you so much, sir. Now, we will be moving on to the next technical session. Respected members, please note we will be moving on to the next technical session. She will be back in 2 minutes. I request everyone to please stay back. Now we will be moving on to the next technical session. I invite Dr. Rajashree MS, CEO, Trust Research Park, former Vice Chancellor, APJ Abdul Kalam Technological University for this session. Madam, please.
Good afternoon, everyone. Distinguished delegates, research scholars, faculty members. When I was invited by Anil sir for this session, I was not very clear what I should be speaking on such a gathering of industrial engineers, because industrial engineering was a very new topic to me. I didn't even learn a subject in my undergraduate. So that's okay. Then I was thinking about industrial engineering, and I am a computer scientist, basically, a computer science student from my undergraduate onwards. My PG, PhD, everything is in computer science. Then my work also, I haven't really worked on engineering. I was, my 32 years service, I was in academics. Teaching, researching, as someone said, researching and producing papers for PhD, and then becoming a professor with academia and all that. So the stereotype, typical. Then I had an opportunity to work with many institutions in the state with very different objectives and expectations and aspirations. When those institutions were designed, but I'm not very sure if any or some of them are met. So with my experience, I thought I will speak on connecting Industry 5.0 and then industrial engineering. Then after coming here, I listened to Levin sir, the speaker who talked just before me. He was speaking about his park. I am also the CEO of a park now, which is called very good institution, Trust Research Park. Trust stands for Trivandrum Engineering, Science and Technology Research Park, which was modeled along the lines of IIT Madras Research Park. Now, I don't have to explain what the research park is doing and what are the aspirations when such a park is built, because all of us know the value of IIT Madras Research Park now, and it is generating 1.2 patents per day. 1.2 patents per day. So that is why research parks are built, to create IPs and innovations which can fuel economic growth of the country. Now, that is how we are. And at Trust Park, we are in our humble beginnings with 7 companies. There were 8 companies. 1 company moved out now. We have some more space to accommodate more companies. So 8 companies. But the focus here is on deep tech. The companies which are capable of generating IPs and also at the same time bringing academia also along their work in improving their skills and taking real industry problems to the student community, giving them internships. Those are all some mandates that the park is putting forward to the companies that are coming to incubate with us. And the main verticals that we are concentrating now are semiconductors and electric mobility. So when I say I'm concentrating on 2 verticals, what does it mean? When we provide space as a park, it's not only the real estate that's being rented out. We also have some infrastructure that's given to them in the form of EDA tools and an ecosystem for developing their systems in the form of EDA tools predominantly, which the startups will not be able to afford. So that is where we are placed now. Now, coming to Industry 5.0, we have seen that. Now, I'll try to link this with the theme of this event, this seminar, and this you call it the 67th National Convention and the 9th International Conference on Industrial Engineering, and the theme is Industry 5.0. Let us try to link the theme and then discuss about how these kind of ecosystem can bring in some synergy to industrial engineers and Industry 5.0. Now, we all understand that there are 3 fundamental differences between Industry 4.0 and 5.0, primarily being the human intervention into automation, then resilience and sustainability. These are the 3 terms that we use. Now, for me, these three terms are highly overloaded in the sense that how we can have these attributes in the automated system that you make in your industrial engineering workflows or in your industry will be very much dependent on what purpose it is being used for. Now we are all familiar with automated systems for various purpose. One thing that I have noticed, looking at from the computer science point of view, from the technology point of view, from the automation point of view, and the domain point of view, this is what I have been thinking about, how to distinguish between these two. For example, if I have AI as a technology, or if I have AI as some algorithms, we always look for, most of the times when industrial engineers or the researchers, they look at a specific problem and then they address that problem, improving the results of optimization. That's what industrial engineering is primarily looking at compared to mechanical engineering. It's always about optimization, workflow management, improvement, and also not only engineering and technology, but also looks at the business side of it. So mostly it is optimizing something, enhancing something, or reducing something, say a carbon emission, or enhancing profit, or reducing workers, or increasing workers, whatever it is. So when we think of this automation at one end and the actual problem on the other end, where does and how do we plug in these two? That is what is very critical, and this relates to the discussions we had in the panel earlier also. How intelligently, or how do we contextualize industry, how do we contextualize technology for industrial engineering? If we can be clear on that, then Industrial 5.0 will, the philosophy of Industry 5.0 will get addressed. That's what my belief is. That means if you are using artificial intelligence for managing a workflow, I also read some literature using my LLMs, Gemini, and all sorts of things to see how multinational companies are using Industry 5.0 for in their shop floors, what Ford is doing, what BMW is doing, and all that. But they all have some algorithms being used for some specific purposes. There are very interesting literature also available on these. But whatever it is, even if it is a small problem, a factory with say 5 or 10 workers, a small business that is operating, how exactly the technology is being adopted to that particular domain, that is something that we need to look at, and only then it will be very meaningful. It's not that you use artificial intelligence based algorithms or blockchain based technology for that matter. And sometimes people are very fascinated by blockchain and they use it. Blockchains are used for very different purpose altogether, not for just workflow management, but it has some associated benefits and technology enhancements when distributed databases are used. When I'm using blockchain for my workflow, do I need to really use it, or am I using it for because it is blockchain and everybody uses it? That becomes very critical. And when we look at anything for that matter, not only algorithms, but also the cyber physical systems which will be powering the Internet of Things, the industrial Internet of Things, all these are very, very tight tightly coupled with the domains which are used in improving or in harnessing the full benefit of technology. That is a single point I want to drive to the industrial engineers who are looking for Industry 5.0 adoption in their companies. So it is looking at what is the need when I am using an algorithm for improving, or when I am using analytics for having the faulty components in a huge manufacturing product line. Then what are the an analysis that you can make out of the data that is produced from that workflow, and then use it for furthering or improving the processes. And if you are also using manpower associated with that automated system, how does it matter if it is a completely automated system or one that is controlled by humans? That is also one of the attributes of Industry 5.0. How can you make human interventions with technology? So when we are making human interventions, will be concentrating on some of the cognitive capabilities of humans which the AI algorithms fail to bring into the system's workflow. That's what is critical. So for such systems, you involve a human. You give, say, 5, 6, 7, n number of decisions or alternate paths to follow based on something which only human brain can conceive and understand and give a result. Then use the algorithm for the rest of it. Where exactly you are able to do this, that becomes very critical, and that is where the concept that's already described earlier, which during the panel, the design thinking approach. You can, when you're using that human decision, you can have the customer's voice. What exactly do I want to do from my system? Design thinking has now become a very domain-independent technique by which the experts in design thinking can put all of you in a room and then conduct a half-day workshop and then get your expectations, give you a nice report on how you should be building your systems. So this become a very, very fascinating piece of technique which we can use in anything that we build. If I want to make an institutional development proposal for my campus or anything, I can have a half-day workshop, putting all the stakeholders together, get data from them, and you can use many technologies and data gathering mechanisms to make elicit the requirements and then come up with good designs for even designing or conceptualizing an institution. Similarly, we can have all these incorporated and use the 5.0 based technologies in the right sense, which is looking at organizational objectives and the optimizations that we want to bring in the organizations. That is what is more important. So the institutions which are working at the interface of academia and research and industry will be the right places where these kind of systems can be tried out and such models can be evolved. If the problems can be brought to the student community and researchers who are working along these lines, we can have very interesting solutions which can be built and integrated to the industry for that purpose. So with this few words, I don't want to go further at the end of the day. I just wanted to introduce the organization Trust Research Park, where I'm working now and giving the opportunities available. We are also in the chosen as a special purpose vehicle for developing an EV park at Vilappilshala, which is a campus close to Kerala Technological University campus. That is the conceptualization and detailed project report. Conceptualization for the master plan and detailed project report is getting ready now. As part of that, we have also set up a laboratory facility, a drive-train lab in Energy Management Center close to our Trust Park. Trust Park is a Section 8 company with College of Engineering Trivandrum and Government of Kerala as shareholders of the company. It is located close to College of Engineering Trivandrum. So this drivetrain lab facility is for testing of equipments, mechanical equipments, motors and all. And we are discussing with Automotive Research Association of India to have a partnership to have a pre-certification facility in association with ARAI Pune, which will become operational in 3-4 months' time in Thiruvananthapuram. So that will open up wide opportunity for young engineers engaged in mainly EV startups to test their motors and then for stress test and thermal stress test, etc. So these are all the activities that are going on in the park. In essence, the facilities that are created now is part of a major ecosystem that is built to empower the academia also to be part of industrial organizations and for empowering startups working in these sectors to have common facilities, unlike software startups which used to be very lean and not very resource intensive. We have instrumentation facility associated with the lab I mentioned, which will be a 4 crore facility for testing of electronic equipments and systems. So these are all some of the verticals we are working on. Then it is also being planned to expand the mentor network with industry veterans like you people who are coming here, who are ready to work with young talent from the campuses, where we can have internships, projects, and as a result of this, structured academic programs being developed from these. One of the companies that are working with technoparks, you would have noticed in the in news recent days, Netra Semi, it's working on intelligence at the edge devices, IoT devices. That means designing semiconductor chips for intelligence at edge devices like cameras, and these designs are from, it's a bundle of their own IPs. You would have seen in the news, they were able to bring in 107 crores funding from Unicorn Ventures, Soho Corporation and all. They were also part of Ministry of Electronics and Information Technologies C2S project and DLI, Design Linked Initiative Scheme, where crores of worth rupees electronic design and automation tools were available for them. They're also associating with the C2S Chip to Startup project. One academic institution is also part of that. So College of Engineering Trivandrum is also part of this project, where a large number of electronics engineers are getting trained in EDA tools for designing semiconductor chips. So that is a very promising area for us, where the functionality, we used to think that hardware is common and software and systems built out of it. Now we need to reverse that thinking. Everything comes with hardware. The functionality also gets embedded in a laser, and then semiconductor chips will be very special purpose around hardware processors such as RISC-V, which can be used for various purposes. You can build semiconductors around these chips, which are open hardware kind of. So that is something which we need to seriously look at. And personally, I believe that our city has the capability to enhance these kind of initiative, especially in chip design, because it is a very intensive activity which has to be pursued with a lot of academic rigor, with core knowledge in subjects and also platforms to work on for testing everything. It is not manufacturing of chips that's critical, but designing of chips ready to manufacture, that is very critical, and that is one of the main focal areas that we are looking for. And we can aspire that in a few years, 2, 3, 4 years, we will be able to have chips from Thiruvananthapuram for spacecrafts, for healthcare, and many such applications, maybe for logistics applications which can power the automated port that we have, and several such applications. So that's what we need to look up to. Thank you for this opportunity, and I thank the Institute for Industrial Engineers, Thiruvananthapuram chapter, especially Dr. Anil, for having given me this opportunity to come and spend a few minutes with you. Thank you.
Thank you so much, ma'am. Now the session is open for question and answers. Okay, the two have already raised their hands, so we won't be having any more questions. Okay.
Hello, madam, you referred about energy management cell.
Yeah.
So can you briefly indicate what are the activities undertaken? Are they doing any formal energy audits of various organizations?
Yeah, they are doing that. It's an organization, autonomous organization coming under Government of Kerala. In fact, we are using the facility there on rental basis since we didn't have space there. It's not associated with Trust Park. In order to have our facility housed in a building which is close to our center, our Trust Park, we hired some space there, but they are doing that. They are conducting energy audit for organizations.
Particularly, are they doing for designated consumers who are the large consumers of energy? For those organizations, they are doing formal instrument-based audits?
Yeah, I am not very clear about how exactly they do the audit, but in our organizations, we did an audit to have some designs there. You can check the website or contact them directly. In case you want, I can get you connected with them. EMC, Energy Management Center. It comes under Department of Power.
Ma'am, excuse me. I'm Dominic, working in VSSC. Ma'am, as you are elaborating on the design aspects of semiconductors as well as related areas. Where do you propose to fabricate this inside India, or do we have any plans to have fabs or something of that ecosystem in India? Or
yeah, see, all of us are aware of the fact that this is something which is it's not something that can be easily established here with the facility that we have in Kerala. So this company, which are housed at Trust Park, what they're doing is they tape out the chips in Taiwan. Okay. They do everything here and they do it in Taiwan. In India's semiconductor mission, they have also for this project C2S, I mentioned about C2S project, Chip to Startup, which is enabled by Ministry of Electronics and Information Technology. They permit this fabrication at SCL, Chandigarh.
Oh, so they have propose SCL also?
Yeah, SCL for these kind of startups.
Okay. I just asked because I worked in SCL for some
time.
Yeah,
SCL.
Okay.
Yeah.
Okay, ma'am. Thank you.
I'm also trying to connect with other organizations in the country to have this expanded, this software, this chip design capabilities from Trust Park, and then design formal academic programs around it. In the whole India semiconductor mission, which are the missing links where we can also be there, starting from our ITI students to polytechnics to undergraduates, MTech and PhDs, in all these academic programs, where exactly can we fit in and be part of this entire cycle. Probably the Keltron chairman is here. People here will be able to enlighten me more on this, how exactly we can make Kerala a talent pipeline for the chip design industry. We'll have discussions offline. This is something that appears to be very important for us. Now after the IT, the next revolution is going to be chip revolution. So we should not miss that opportunity. Yeah.
Madam, I am Sanesh from Keltron. I am also asking the same area. Madam, you told about semiconductors. So where should we focus in order to increase the production of semiconductor devices in Kerala? We are having some production centers in Kerala, across Kerala. So which area we should focus in order to increase this industry?
Mainly we have to, from the academic side, I would say that we have to be more rigorous on the academic side, making electronic students very rigorously pursue subjects which are the core fundamental subjects in electronics. After that, we have to have some mechanisms if not in all colleges, at least some institutions, some lead institutions which can have the laboratories enabling students who are interested to work on this. And then probably we need to take it up at a higher level like Keltron or some agencies like that. If we can work together, we can have a plan for the state for developing talent in chip design. In the whole life cycle, where which all places we can fit in and then create talent. We may not be able to look for a fab or something which requires extensive infrastructure. Probably we will have talent who can go to Gujarat or Chandigarh or Taiwan to tape out their chips. That's what we should be dreaming at large. Okay, so that's it. Thank you.
Thank you. Thank you so much, madam, for that informative session. Now, I request Dr. Suresh Kumar to kindly present the token of gratitude to our esteemed guest, Dr. Rajashree madam.
Hello everyone. Now I request Sri G. Levin to accept the CEO Conference Book of Abstracts from our National Convention Secretary Yogesh. So our Prasad Rai sir will be handing over the Book of Abstracts to Sri G. Levin, CMD, K-Space.
Thank you so much. Thank you so much, sir. Now we will be having the tea break. We will have a 10 minutes tea break. Please be back within 10 minutes. Delegates, please note, now we will be moving on to the next technical session, which is led by the Vice Admiral Sri Kumar Nair, sir, retired, Managing Director, Keltron, AVSM. Sir, with all due respect, we invite you, sir.
Shall I start? Dr. B. Anil, Chairman, Indian Institution of Industrial Engineering. Dr. B. Bijulal, the Secretary. Dr. Narayan Murthy, Chairman, Keltron Group. All the distinguished dignitaries, I'm not taking everybody's name, all the distinguished dignitaries present here. Members of the Institution of Industrial Engineering, ladies and gentlemen, a warm good evening to each one of you. Dr. Anil met me about 2 weeks back and asked me, sir, can you speak on, the opportunities in the defense sector? So that's why I'm here, and I thank all of you, sir, and your chapter for inviting me here to deliver this talk. What I will do is I will generally touch upon initially with the budget that's available, because the budget drives, the business. So what's the budget that's available? I'll cover the 3 services, the Coast Guard also, the DRDO. We have ex-director of NPOL here. He will agree with me when I'm talking, what's the budget that is available. Then I will go to the specific opportunities. I'll take the example of the Indian Navy and drive home the example how what's spent in the revenue, what's spent in the capital. Capital, when I talk about, is when you go for acquisition, that is, you create your infrastructure or create your assets. Yeah. And then the revenue which goes into, doing up your maintenance, repairs and what have you. So I will cover it in that aspect, and finally cover on the technologies that are looked into by the services. If you look at today, what's the defense budget? Is 6.81 lakh crores per annum. This is 25-26. Out of this, 1.8 lakh crores is for capital expenditure. 1.8 lakh crores annually is spent on capital. Of this 1.8 lakh, 1.5 lakh crores is spent on acquisition. Acquisition, when I talk about, let's say, the aircrafts that the Air Force buys or the ships and submarines that the Indian Navy buys. And of this 1.5 lakh crores, what's interesting is that 75% has to be through the domestic sector. 75% of this 1.5 lakh crores has to be spent through the domestic sector, and of this 75%, 25% through the private industry. So the opportunity is not just for the PSUs and the big players, but the private industry too. Coming to, the revenue part of it, of this 6.81 lakh crore, 3.11 lakh crore is the revenue budget, of which, it's very interesting to note, 1.14 lakh crores other than salaries it's spent, 1.14 lakh crores, of which 50,000 crore is for the maintenance assets. That is repairs and maintenance. So if you look at the revenue budget, when you want to do your, repairs, maintenance, reinstallations, etc., your 50,000 crores is annually spent. Look at the DRDO budget, which is primarily, DRDO is primarily the agency for all defense R&D. The R&D develops a product, out of that comes out a product which is again transferred to the industry to manufacture. Out of the 27,000 crore outlay for the year, 15,000 crore is capital acquisition and project funding. So DRDO spends on prototyping and project funding, 15,000 crores is the available budget from DRDO. Now, another area that defense has started is IDEX, Innovation for Defense Excellence. This is primarily to encourage the startup ecosystem in the country. This can be bid only by the startup ecosystem, only by startups. There are 450 crores allocated for this. I will come to details of this subsequently in a slide. What does this contain? So primarily focusing on innovation through the startup ecosystem. I have also taken Coast Guard into account because Coast Guard, almost similar to what the Navy does. The outlay is about 9,700 crore, of which 5,000 is in capital acquisition and 1,200 crore is for maintenance and repairs. So that's another area that the industry needs to really tap. Now I'll come to specific example. I'll take the example of the Indian Navy. Indian Navy's outlay is 97,200 crore, which is 20%, close to 20% of the defense budget, of which 65,000 is spent on capital acquisition. That is 35% of the capital acquisition of the armed forces is spent by the Indian Navy. What is this spent on? Construction of new ships and submarines. I'll come with specific example of what are the opportunities that happens in new ships and submarines. Modernization of the existing fleet. That means if you have a 140 ship, which is typically the Indian Navy's assets, 140 ships and 16-odd submarines, they need to be upgraded periodically for maybe its propulsion system, for its engines, for its hull, for its weapon systems. So modernization, it's spent on modernization. Then infrastructure creation, which could be jetties, civil works, and various other things. So if you look at a new construction ship or a submarine, how do we proceed? The Indian Navy typically goes for an in-house design. There are Directorate of Naval Designs which designs the ships, which is the hull form, what equipment to go in, what engines to go in, what generators to go in. And submarines, while most of it has been through a partner, but now soon you will see most of it will be done in-house. The next generation submarines all going to be done in-house. The shipyards who are associated for this construction, the Cochin shipyard, we are all aware of, close to us, the Goa shipyard, which is the GSL, GRSC, which is in Calcutta, that's the Garden Reed Shipbuilders, Mazagon Dock Limited, which is Mumbai, Hindustan Shipyard at Visakhapatnam, and L&T at Kattupalli. These are the primary creators of the ship, and submarine is primarily at Mazagon Docks Limited. Submarine upgradation is done at Hindustan Shipyards Limited. So these are the shipyards where most of the money is for capital acquisition comes in, and that's where the opportunity for the industry comes in. Now look at, we will take a classic example. We'll take an example of a destroyer class of ship or a frigate class of ship. When I say destroyer class of ships, they are, typically about 6,000 to 8,000 tons. They will have every kind of weapon that you can think of. That's the missile systems to guns, to radars, to sonars, torpedo tubes. They can do about 32 knots. 32 knots, when I say it is into 1.6, which will come to about 50 kilometers an hour. So it's a city by itself, which will have 4 to 5 megawatt of electric generation distribution. It works. It's manned by something like 450 people. 8,000 crore is typically 8 to 10,000 crore is one destroyer, or a frigate will be slightly lower than that. Here, what opportunities? You have opportunities in every sector. That's fabrication or hull, that you make the ship's hull, the form of the ship, that is 15% of the cost of this, roughly 15%. So that's for the industry who deals with, fabrication, piping, plumbing, all kind of works. Engineering, when I say I'll come to what I mean by engineering, that is about 25%. The electrical systems is about 10 to 15% of the cost, and balance is the weapon and sensors, which comes to 45 to 50% of the cost of the vessel. What is that opportunity in fabrication or hull, which I said 15% of the cost, which is almost running to 1,200 crore for one ship? It is the hull fabrication. That means the steel that is used has to be fabricated to make the hull form. in whatever form. You can see various ships, various forms that you have. A ship could have doors and hatches running into hundreds. An aircraft carrier would have something like 250 doors and some 800 hatches. So that's the opportunity for, those kind of works. Boats, cranes, everything. Boats you have to lower. You need cranes on board every ship. Piping, if I tell you about cabling, which runs is almost 60,000 kilometers of cabling on an aircraft carrier. The piping would run something like 15 to 18,000 kilometers in a ship or in a ship of that size. So that's the opportunity for the industry for piping, plumbing, hydraulics. A lot of things run on hydraulic systems. Hydraulics are required for powering, operating davits. Structures. If you see some of these ship, these are weapon systems installed. You have to make these structures. There's a great opportunity on these structures because they have to be manufactured and fitted on the hull form. Primer and paint are very important. You need to have long life paints, primers and paints, anti-fouling paints, etc. That's an opportunity as far as this 15% of the cost of the ship is concerned. Now we come to engineering. Engineering, in the naval parlance, when we talk about engineering, there are two big aspects. One is the engineering and one is the electrical and electronics. So engineering would cover everything that's related to mechanical aspects. It could be the engines and associated auxiliaries. Mostly it is diesel and gas turbines. You also use certain steam ships. You would have heard of the aircraft carrier Vikramaditya, where it's a steam ship. Generators, on a typical frigate, you will have 4 to 5 megawatts. In an aircraft carrier, it runs to 10 to 12 megawatts of power generation. And that's generated either through diesel generators or gas turbine generators, and the auxiliaries that go into these generators, whether it's cooling systems, fueling systems, all that is a great opportunity. And that itself has got a lot of piping, plumbing, what have you. Air conditioning systems. Typically, a destroyer would have something like 125 tons into 8 air conditioners. Valves, pumping systems, I already spoke about. The steering, control systems, and sewage plants. As I said, it's a city by itself, so you need to have sewage plants and what have you, toilets. So the opportunities is like a city. Whatever you do in a city, everything has to go into that limited space to create this. So that 25% of that 8,000 crore for a ship goes into engineering, propulsion, and power generation. Then comes the electrical, which is the 15%, which is power distribution. You generate 5 megawatt, you need to distribute it to your consumers. That's why I said so many kilometers of cabling, various types of cabling. The main line run could be there, which is primarily 380 volt lines could be there, and the distribution lines, which is you would have stepped down to 220, you would have gone into 400 hertz, the converters, etc. So conversion systems, whether it is rotary or static, lighting. Imagine a ship of that size, how much of lighting that goes into thing. All kind of lighting. You can have halo deck lighting, because if you want to have your aircraft taking off from the deck, you need proper lighting on the deck. You can have the compartment lighting, you can have the bridge lighting. So all different kind of lighting. Cabling for power distribution, motors. Typically a destroyer would have something like 280 to 300 motors. That's the number, and of various capacities that goes into. And the control systems for this. Look at weapons and sensors. This is almost 50% of the cost of the ship. 4,000 crore almost goes into the weapons and sensors. So that's what have you. Radars. You need long range acquisition radars. You need short range. You need tracking radars. And you need missile systems. You have surface to surface, surface to air missile systems. Guns, you need short range, long range gun systems. They are typically fitted in the front of the ship, the long range, and the short range would be somewhere here. Missile systems would be here and here. They could be vertical takeoff, they could be inclined launched. Sonars, which could detect the submarines underwater, and to attack the submarines you need rockets and torpedo systems. Communication systems to communicate between ships, ship to submarine, ship to land, and you need electronic warfare systems. Why do you need what is electronic warfare system? It's nothing but passive listening. In a conflict scenario, you're never going to transmit on your radar. You are going to first be passive listening to see somebody else's transmission. So you need electronic warfare systems. So the tremendous opportunity, and 75% of this capital budget is going to be spent in India. So imagine the amount of money that's available for each of these things. Now, how does the weapon and system, which is 50% of the cost, how do we, Navy, so Navy develops firms. I said the PSUs take about 75% of the thing, and then the DRDO research. So DRDO understands the Navy's, Army, Air Force requirements. They do a research. They, through the industry, develop certain products which are again, plowed back by Navy nominates when a ship is made. So primarily, if you look at weapons and sensors today, who are the major players? Bharat Electronics, Bharat Dynamics, BHEL, L&T, Tata, Mahindra Defence. We contribute typically about 100 crores. Keltron contributes in a year to defence. Yes, yes. Bhopal, correct. That went into the Brahmaputra class of ships. The Hindustan Aeronautics Limited. So when you have these PSUs, what happens is an ecosystem is automatically created, because the PSU by itself is not doing everything. They are more majorly system integrators, and the smaller parts would be made by various industry, whether it's a PCB, whether it's a sensor, whether it is cable, whether it is cable looms. So that develops a huge ecosystem in the country. And when we look at what are the technologies that's focused on, So what are the technologies that an industry or industries and research institutions and academia should focus on for not only the Navy, but all three services? Sensors, be it microwave. Frankly, to say that, not much of, hardly any microwave sensor is made in the country, which mostly imported. So that's a huge opportunity how to do this microwave. Underwater, yes, we have, thanks to the Naval Physical and Oceanographical Laboratory, we can be proud of, which is located in Kerala. We have a lot of self-sufficiency in this. But even in that portion, maybe, we have another 30% to cover. Vibration sensors, gyros, optical sensors. You have electro-optical sensors, FLIRs, infrared imaging. And when you have a sensor, you need signal processing. You need signal conditioning systems. Whether it could be the front end, whether it could be the preamplifier, whether it could be the processor, all those stuff are required. So that's another opportunity. And control systems. If you have a gun mount, if you have a missile system, you need to have control system, because once you have picked up a target, how do you lay your gun to that direction? So you have control systems which could be electric, electro-hydraulic and electro-pneumatic. And command control systems, which are primarily, controlling your entire action scenario and ensuring that missile is delivered or ammunition is delivered on the target. In the engineering parlance, if you look at propulsion systems, see, today, if you look at it, the gas turbine generators are not made in the country. Though we have various efforts, but the gas turbine generators still gets imported, either from, mostly it used to be from Russia. Now we also get the LM2500 from US. The shafting systems, because the shafts have to run through the entire length of the ship. That's another great opportunity. Pumping solutions, you got to have, because your ship is so huge, you have to have huge pumping solutions for your fresh water on board. You want to have your fuel on board. You have to have pumping systems. In case of an emergency, you have to have a pumping out systems. That's again opportunity. Anti-fouling paints, because your hull has to be protected. You need a good in-house capability on anti-fouling paints. Radar absorbent material, that means your ship or a submarine at long distance should not be detected. So how do you go for radar absorbent material? If a radar is transmitting onto you, it should be in such a way that that frequencies are absorbed so that you are not detected. So that's a great opportunity. Stealth technologies. If a ship is at sea, there are a lot of rotating machineries. That rotating machinery sound can be picked up by a sonar at long distance. So how do you reduce this noise? That's, as the hostilities become larger, you need to have more and more stealthier platforms so that you are not detected. Now, that was, about the Navy, and similar thing would be for Army and Air Force. Now, the DRDO. DRDO, what it does, it focuses on what the armed forces requires by fundamental R&D. They do direct funding, because I showed you the 15,000 crore is the outlay for that, and funding by the armed forces. The Navy could fund a project for what it requires to the DRDO. That funding comes in. Now, R&D labs would design the product. Productionizing would be done by an industry. It could be private. It could be a PSU. Like, we are strongly associated with NPOL. We do a lot of their part which they design. We tend to manufacture. And if an industry gets associated at this stage, the importance is that once that product is developed, the armed forces nominates that product through that industry. So the next few series and their upgrades is assured now to the industry. So that's the biggest benefit that the industry gets, which I told about subsequent TOT and opportunities. Now we looked at the capital part of it. Look at the revenue. Revenue budget is, of the 32,000 crore, almost 40% is for repairs, maintenance, and logistics. That's for the fleet to be maintained. Maintained, when I talk about, a radar can have a fault, a motor can be overhauled, a piping system has to be replaced. All these are part of the repairs. The pump can be overhauled, pump can be replaced. So that itself, there's a huge opportunity of, almost 32,000 crores that's available annually. And these are typically, now you see, where does this take place? I spoke about the industry where it comes. Where does the repair and maintenance? That's where the revenue budget goes in. You have two primary dockyards of the Indian Navy, which is at Mumbai and Visakhapatnam. They are like, spread over almost 900 to 1,000 acres of land with jetties which span something like 25-26 kilometers, because you got to berth these ships and submarines, all kind of facilities for fueling them, maintaining them, everything exists. So that's maintained through Mumbai and Visakhapatnam dockyard, where the revenue budget is spent. It could be internally, or it could be through a firm, which could be a private firm, a PSU, for repairs. So that's a huge opportunity. There are two naval ship repair yards, Kochi and Karwar. They are smaller in size, but they also, rather than in-house capability, they do a lot of offloading. So the industry has got a huge opportunity there, because most of the work is done by outsourced offloading. The Navy also offloads ships for, to shipyards for repairs. That's another opportunity. So opportunity exists in every field, whether it is capital acquisition or repairs. So similar opportunity, if you look at the Army for its tanks, what have you, missile systems, the Air Force for its, fleet of aircrafts, the similar, and its ground-based radars exists. Coming to, I said that's the opportunity in capital and revenue. Now, this is an important point, an IDEX, because this is to develop cutting-edge technologies through startups. This was started in 2021 by the Ministry of Defense, directly funded. Twice a year, what is required to be, what is required for the armed forces through these IDEX challenges are put on the MOD website. The startups can bid for it, and the beauty of this is that if the IDEX challenge is brought out in such a way, you want a communication system, you'll say that you develop this, 50% funding by the Ministry of Defense, 50% funding by the private, but If you have proven it, there's an assured order quantity of 10 or 12. That's published along with the IDEX challenge. So the industry is that way protected, that the challenge is you put 50%, but you prove it, you are assured of the larger volumes. So this is price, and 450 crores are allocated for this, for the IDEX challenges. And even in Kerala, there are a few firms which have bid for this, and they are, building whatever is required on the IDEX challenge. The future, now I spoke about the present and destroyers and whatever the acquisition. The future for the armed forces is going to be autonomous. While you have your own ships, submarines, aircraft, tanks, etc., the direction that which it's going is for automatic aerial vehicles. You have seen how drones were, used all over during Op Sindoor, or the recent Ukraine-Russia war, or even in Israel and Gaza. AUVs, I've shown an AUV, autonomous underwater vessels. These are all unmanned vessels. This might be just about 50 tons, 10 meter by 2 meter dia, but it will be fitted by a plethora of systems so that it can maneuver, detect what you want, transmit, maybe come up, transmit to the destination from where you can engage your enemy. So these are going to be the future. Automated surface vessels, that means boats which are autonomous, which can do high speed. Maybe 60 knots, 65 knots, that's the next target. 65 knots means it's almost doing 100 kilometers an hour. And then the swarm systems. Imagine the AUVs, 10 AUVs operating together. They're operating together in a swarm like the bees fly in. So, it's very, very difficult and challenging in an environment that's hostile. Imagine 10 swarm boats attacking you, in unison, communicating to each other, and that's the future of warfare on which all the three armed forces are working on. In fact, there are many IDEX challenges on this, which industries are already taken up, and there's considerable funding that's happening. Not only this, the DRDO is also working on these systems. So finally, I wish to say that, the budget outlay of the armed forces combined with positive indigenization list, this is important. The armed forces has got something called a positive indigenization. That means this will not be imported. So that list is available in the MOD website. That can be only sourced from the country unless the DRDO says, yes, we are still not mature and we need to import. And the present, geopolitical situation, most of our systems, are from Russia. What's going on in Russia, Ukraine. So there is an opportunity there to indigenize those parts. And also we have systems from, Israel, where again, what's going on. So, and such a conflict scenario, it's a very good opportunity for the industry and startups to take up and ensure that we use this budget effectively for the growth of our industry and in turn the growth of our economy. I think thank you so much, and thank you.
Thank you. Thank you so much, sir. Now the session is open for question and answer session. Do we have any questions? Okay. Thank you. Thank you so much, sir, for that informative session. Now I invite Levin, sir, to kindly present the token of gratitude to our esteemed guest, Srikumar, sir. Thank you. Thank you so much, sir. Now we will be moving on with the next session. Delegates, please note, we will be moving on with the next session. I invite Engineer Balram S., CEO, ACTIMST TI Med for the session. Sir, please. Delegates, please note, now I invite Balrams S, CEO, ACT IMST TIMED for the next session.
Good evening, friends, and a few empty chairs. But I understand it's because we have parallel sessions going on. I happen to be a student of Professor Anil, the organizing secretary. I guess he was my favorite professor, and I guess I was one of his favorite students. So he asked me to come and speak, and frankly, I had no clue what the theme of this conference is. So I took the liberty of coming here unprepared, and I must apologize if it's something of not of interest to you. But in the previous sessions, I found the theme is not only about AI, it's also touching about human emotions, AI with a human touch. So what I'm going to talk about is human touch without the AI. And I come from the healthcare sector, so we heard about space, we heard about semiconductor, we heard about defense, but I think finally we are all human beings, so health is also important. So I thought I'll just share my thoughts on this, where good ideas come from. So there is a book by it's a bestseller book on Amazon, you can find it, where good ideas come from. And it has given some structure. But what I thought, sometimes good ideas come from just conversation with strangers, just an exchange of ideas. So my talk is all centered about this, how conversations with strangers, maybe in a conference like this, could have an impact which none of us would have thought of, and which would have impacted all of us, the humanity as such. So this is early 20th century. Infant mortality was a very pressing problem. Newborn child deaths. This is the Paris Museum, Paris Medical Center. And one of the obstetricians there was pained that so many babies are losing their lives and he is not able to do anything. So one day he walked to the adjacent Paris Zoo and he saw that in one of the cages there was a small wooden box in which certain eggs were kept. And he talked to that zookeeper, Oldie Martin, and he discovered that that was a method of providing a warm environment so that the eggs will hatch. So that idea struck him. He went back, ideated, and then he came about with a design and a device, which is the first concept of a baby warmer or a baby incubator. Now this is one and then it became, the story goes that it became a fashion. Sometimes there used to be fairs where parents used to showcase their babies in these incubators. And finally we have the modern incubators over a lot of innovations, etc. Now another, we come to 1978. We know that these kind of notebooks are there in every research labs. So this is one particular page from a notebook. And in the blackboard, something the researchers are excited about. Now it so happened that one of the researchers made a breakthrough. He made a breakthrough because he was able to manipulate the genes. So he was able to take gene from one organism and put it into another organism. And naturally he published it. All scientists, when they make such breakthroughs, they publish it. And when it was published, a lot of other people from the scientific community took note of it, and he was basking in glory. He was giving press conferences, he was being invited to speak, etc., etc. And there was one youngster, Robert Swanson, 29 years of age. He had done his MBA, and then he had made some, he had started his career as an investment banker, then lost a lot of money, and he was jobless. He was thinking, when he saw this newspaper report, he was thinking, does this have any commercial value? How can I or we make use of this scientific finding? So he tried to reach out to Professor Boyer, of course on a landline. He kept calling him, and Professor Boyer was being invited to speak. He didn't have time. So after a lot of pursuance, he said, Professor Boyer said, okay, I'll give you 10 minutes, come to my lab in the University of California. So this young person goes to his lab, and he puts that spark of an idea into this professor. Do you think this has some commercial value, which that professor never thought of? And then, because this person was so persuasive, the 10-minute appointment extended. They both went to a nearby pub, and over some beer, they charted out. In fact, on that napkin of that pub, they made some business plan. And that led to a whole new industry, what we know today as biotechnology. So that is how Genentech Corporation came into being. And Genentech Corporation changed the face of the earth by bringing biotechnology to the whole world. The Bay Area of California, as we know today, is one of the most fertile scientific hubs. And all those companies owes it to this serendipity, this interaction. So we don't hear this term Genentech because it was acquired by Roche, but it is one of the biggest biotech companies. Now, something about sports. So this is a famous sport in United States, rugby, a very rough and tough game. So one of the, and all the universities have their own sports team. So one of the universities of Florida, they have a good rugby team. But the problem they faced was the players did not have the stamina. They were not able to withstand the game. They used to be drained out. So the football coach, he thought, why not solve this? So he went to the chemistry lab of the University of Florida and started talking to some professor there. I have this problem. Again, conversation with strangers. So he met Professor James Robert Cadd and discussed his problem. So the scientist doctor soon realized that the players were getting exhausted because they were sweating, and along with this sweat, all these electrolytes were draining out. So they have to be rehydrated. They have to be rehydrated very quickly. So he came with very simple combination of sugar and salt. We know this ORS, oral rehydration. So it's a specific formulation of that was developed by this professor. And now when this was given to the players, they got the stamina And the team of Florida rugby team was called Gators, the Gators, and this drink, Gatorade, came into existence. But what is important is this Gatorade, this small idea became almost like $1 billion industry. So it is an idea that actually launched an industry of entire rehydration sports drinks, which is a multi-million-dollar industry. And the university gained immensely because a lot of the royalties which came from this technology transfer came back to the university. Now, we always hear of these success stories from the West. What about our country? Do we have something like this? So anybody from the life sciences sector would know this is an agar plate which microbiologists use. And there could be no bigger honor for a microbiologist because this was something etched on a plate by the American Society of Microbiology honoring an Indian microbiologist. So he is Dr. Vishal Warkhe. So he was studying in the University of Mumbai. When he was a research scholar, when he was doing his PhD program, like any other struggling student, he didn't have access to funds to buy the expensive reagents. So he was like many research scholars get married, so he was also married, and his wife suggested, if you can't buy those chemicals, can't you make it yourself? So what he did in his own small flat in Mumbai, in his small kitchen, he started making these reagents using pressure cooker and things like that, kitchen utensils. Then he was able to publish his papers. So his guide was surprised. From where did you get this? Then his colleagues were surprised. So they said, we also want this. So he started sharing it with them. Slowly the word of mouth, it spread. And today, this is one of the world's largest biosciences company. So this is Dr. Warkhe with his wife who gave him that idea during a random conversation. He's having $1 billion company in India and supplies to all the developed countries. Anybody can identify this young girl? I don't know how many numbers are there. That figure is so huge. A small girl from Bangalore, that's a clue. Yeah, exactly. So she was again a science graduate in Bangalore. Then of course, she went a different path. She started, she got a course in brewery, and then she got a job in Ireland. She was almost trying to go to Ireland when a brewmaster, somebody called her, said, don't leave. You remain in India and supply to me. So she took that opportunity. She took that risk and started supplying some reagents. And then that grew. So from very humble beginnings, it has grown into again one of the largest biopharmaceutical companies in the world today. First India's self-made women billionaire. So we'll come closer. How about our city? Something we can identify. That center building palace is where I work. That is the settlement palace of Sri Chitra Tirunal Institute for Medical Science and Technology. I'm also, my degree says industrial engineer, but I don't work in industrial engineering. So, but last 3 decades I have been working in this institute, and I'm very proud of that. And this person, young person, who is basically an economics graduate, knew nothing of science, walks in, and that's Professor Ramani, my former super boss. And Professor Ramani convinced him. They didn't know. It was just accidentally he met him. And Professor Ramani convinced Balagopal that he was born to make blood bags. And Mr. Balagopal was actually at that time an IS officer, just around 30 years. And he quit his rosy career. He took that plunge into this unknown area. And today is one of the largest blood bag manufacturer in the world. This is his company. Again, he has sold it. He has exited that company and acquired by Terumo. Terumo is again Japanese giant. And thanks to the technologies developed from our institute, Trivandrum is one of the big hubs of medical devices manufacturing. So what I was trying to say is science to entrepreneurship is possible. It's tough. And science and business always considered as two different disciplines, but they are linked. And the reason why I shared this is because that is what I try to do. That is what my job is at this institute, to do technology transfer, to link the institute scientists with the industry. And I also have set up an incubator called TimeEd, which is catalyzing medtech innovations. Any entrepreneur or an innovator anywhere can get in touch with us. We give them a platform to ideate and take forward their ideas. So that's all I thought I'll share with you at this fag end of the day. And before I close, a small trivia. These are all very famous brands. What could be common between them? So Intel, Sony, Dolby are all very tech companies. Subway is like a chain food restaurant. They were all founded by people who had PhDs in physics, including Subway. Yeah, so that's all I wanted to convey. Thank you for listening.
Thank you so much, sir, for that beautiful session. Now it's time for the question and answer. Do we have any questions or doubts? Do we have any questions or doubts? Okay, thank you. Thank you so much, sir. Now I invite R.A.D. Pilla sir to kindly present the token of gratitude to our esteemed guest Balram sir. Thank you, sir. Thank you so much. Now we will be moving on to the next technical session. Delegates, please note. Now we will be moving on to the next technical session. I invite Dr. Brijesh Madhavan, CEO, Curve Logix Advanced Technology Solutions, for the presentation. I invite Dr. Brijesh Madhavan, CEO, Curve Logix Advanced Technology Solutions, for the presentation. Delegates, please stay back for a moment. Due to unforeseen reasons, Dr. Brijesh won't be able to lead the session today. We will be moving on with the quiz session within 10 minutes. There will be a break session till then. We'll have a 10-minute short break as due to unforeseen reasons, Dr. Brijesh Madhavan won't be able to make it today. So we will be having a 10 minutes break session, after which the quiz session will be followed. Thank you. Thank you all.